Test. Can you guys hear me? Okay, cool, thanks. All right, can everyone hear me okay? Cool. All right, thank you guys for coming out to this kickoff of the B-Side Salt Lake City virtual conference, quarantine edition. I'm Bryce Coons. I'm the president of the nonprofit 501c3 that runs the B-Side Salt Lake City event. So, as you guys are all aware, right, the C19, it's spreading throughout the globe. So we kind of had to change the format of our conference a bit. So thank you guys for all, sticking with us and yeah, and tuning in today. Today, there's already been 80 firm cases in Utah. So it is spreading across the US. So we're just trying to help be a part of the solution of slowing that down at least. So, and CDC has issued that there's not to be any large meetups, which we generally have over 250 people every year. So yeah, so it's nice we still get to do it virtually, and hopefully, yeah, you guys will be able to interact with Slack and the CTF and all that. So I think it's already off to a good start. All right, so the plan, because I know there's a lot of questions about this, I've posted a lot of answers in Slack. So hopefully if you've been in Slack, you've seen some of those. But the plan really is a virtual event today and tomorrow. I mean, originally we're just gonna have talks on Saturday, but now we're having talks both days. All the talks are 25-minute format, so like in 30-minute blocks, so they're quicker. So hopefully, if you just have a few minutes on Saturday or Friday today, you'll be able to tune into the ones you're most interested to, or just kind of leave it running in the background. The schedule is up on the website. There's a link when you click on the schedule to the Google Doc, and the Google Doc is the latest information, although some of the information looks prettier on the website. Really appreciate all the speakers coming together. Kind of changed this to a virtual format pretty quickly, and all the speakers were great, and we still pretty much have the exact same lineup that we had originally, so that's great. And then I just wanted to reemphasize a big shout out to the CTF and Laura, so from Secure Code Warriors, for putting that on for us. We do have some prizes like Nintendo Switches that we're going to mail out to the top performers there. So, if you're interested in learning more about how to secure code, definitely jump on there and work on that. That's something you can work on today and tomorrow. It will be open until 3 p.m. tomorrow, I believe. And yeah, if you have any questions, jump in the CTF channel on Slack, and Laura, yeah, she'll get back to you. So. Right, so tentative plan right now is we want to do a hangout later in the year if it's safe to do so. Obviously CDC and others will have to declare it safe. And then at that time, anybody who's bought a ticket will give you your electronic badge if you purchase that. And then we do have like hats and other stuff. So we'll give that stuff away at that time as well. We may have a CTF and kind of ad hoc talking, like lightning sessions at that, but really that's more of a hangout just to give out the swag. So anybody who can't make it to this hangout, if you email info@bsides.saltcity.gov with a copy of your QR code or your receipt, we'll make an effort, a best effort to mail you your electronic badge and all that. So I'm doing our best. We're doing our best to try and get you guys the stuff that we were originally planning to give you. And then I don't know if you guys have ever seen that movie Pineapple Express, but if this thing starts lingering around, right? So we can't really hold an event this year, then we will honor all the 2020 tickets at a 2021 in real life event. So if you sponsored or you purchased a ticket and we're unable to do that in real life hangout, then you won't have to you won't have to buy a ticket to the next event. So hold on to your QR codes. All right, and then huge shout out to the sponsors. Really, the event would not happen at all without the sponsors. The bulk of the revenue for the event to hold it comes from the sponsors. So I just really want to say thank you to them and for their patience through this really unusual time. DigiCert, RSA, Adobe, Stage 2 Security, Mimecast, CoreLight, Red Canary, SaltStack, SaintCon, No Starch Press, and Redpoint Security. They all significantly helped provide this event for you today. So please go check out their websites and check out what type of offerings they have that might be able to help you guys. So if you want stuff mailed to you or anything like that, like if we're unable to hold the in real life hangout this year, just shoot an email to info@bsidessaltcity.org and we'll get back to you. So So I really don't want to have a bunch of swag sitting at my house. So I'm going to do everything in my power to get that out to you guys. So, but obviously I just don't want to, spread the virus or something weird. So, all right. So, yeah, and just really appreciate everyone's patience as we're going through this. All right, so I just wanted to talk for a minute about the future. So kind of in an unusual time right now where things in society may be changing, kind of on the level of like, I don't know, a 9/11 type event or the financial crisis type event that we had previously. And it is info@BsidesSLCcity.org. Right, the same as the website, right? So sorry if I misstated that previous. So it's, it's an interesting time to be alive. And, I really think if we, collectively put our brain power together, that we're going to make it through this, and, society as a whole is going to be better off, right? So I think the big thing is trying to band together against, common enemy, right? I'm not a doctor or a virologist or a subject matter expert. I mean, I am, a subject matter expert in the cybersecurity field space. So I'm just kind of looking at what's happening in the world and applying it to the cybersecurity field space here in this presentation. So, so don't take this as like, medical advice and whatnot. I'm not qualified to provide that to you. Right, so history of pandemics. So,
I can't get the answer to that on app.
Most recently, we had the Spanish flu about 100 years ago, right? So, human history does have a trend of these epidemics happening, and large swaths of deaths occurring when these potentially outbreaks occur. So, it's pretty interesting. But what I think makes this interesting in the cybersecurity space is just how, now that we have more technology than we did in the 1900s, how that's going to really shift our society and how things are going to change going forward. Right. So what change is going on right now? And so as you guys are probably aware, or maybe not, the states of California and New York have signed laws or executive orders to basically enforce that people stay home, right? So they're trying to slow the spread so that our hospitals and other medical facilities aren't overwhelmed as people get sick. So here we see a tweet from the governor of New York and a picture of the governor of California. And, New York's saying that they're going to enforce this, right? They're going to fine anybody who comes outside of their home unless, they're in the pharmaceutical or grocery or other, needed industry right now. So that kind of reminded me of that classic movie, Judge Dredd, just kind of a futuristic type society. So, what's the future going to be like? It's going to be like a dystopia type Mad Max scenario? I mean, probably not, right? But I mean, it is going to be at least for the near term, it's going to be a lot more isolated, right? And really right now, I don't think, anybody knows how long this is going to last. So there's some predictions out there on it, but, it could be longer or shorter than what people are thinking right now. Right, so right now, social distancing, I'm sure you've all heard about that in the media, right? What does that really mean? It means like virtual meetings like this and remote work, that all starts to become the new norm, right? Instead of you being that weird person who works remote at a company where everybody else is at the corporate headquarters, now nobody's coming to the whole corporate headquarters because of the spread, right? So, and and so I just feel like companies, maybe if you work in the tech industry, remote work was already commonplace for your company or your industry. But, there's a lot of other industries where, they maybe didn't even have VPN solutions or other ways of doing secure remote access until recently, right? So, there's a lot of, industries that have been around a lot longer that are going to have to adopt to this type of model, at least for the near term, right? So, and instead of just some employees being remote, it's pretty much everyone's remote, right? I've personally been on so many conference calls this last week, and because schools are closed pretty much across the nation, it's just the norm. Like everyone's kids are jumping up in the background and waving, and when you're in like pretty serious business calls, right? So it's just something that I think we'll probably we'll get used to more, and families will try to adopt to the scenario more. So yeah, so. Yeah, and I agree, man. I definitely, like my space. I have like the Bryce bubble, right? I don't like people coming too close to me. I'm not really like a huge hugger. If some of you know me or see me at conferences before, so it's not too bad for me, but for most people, I think this is pretty inconvenient for them at this point. All right, so how does this whole scenario apply to cybersecurity, right? Like we can talk all day about the current state. I'm just kind of telling you what I've seen in the news and what I've researched. Every day I look on my phone for articles about, C19 and how it's affecting society, just because more I want to see where the trends are going. And it seems like speculations are pretty wide, right? Between people saying, oh, this is going to blow over in a couple of weeks, to other people saying this is going to be like a 1.5 year thing, right? So it'll be interesting, but regardless, for the now where people can't even go to work, they're going to need some way to securely do remote work, right? So, that could be something as simple as VPNs deployed at their work with their machines still running so they can, hit the VPN and then RDP into their boxes, or to something much more advanced, right? So I think, this type of services are definitely going to go up, right? And so security around remote access and whatnot, as cybersecurity professionals or people who are interested in the industry in general, we're going to have to, put more scrutiny here. Not that there hasn't been a lot of scrutiny here in the past, right? Because, if you had remote access, you wanted to make sure it's secure, because generally, you have this nice hard shell on the outside of your corporation and your protected networks. And the way to get through that is the VPN. But then once you get through there, you have that nice, delicious inside. It's like an M&M, right? Hard candy outside with delicious soft chocolate on the inside. So if an attacker could get a foothold on the inside, a lot of times they could just move unrestricted across a bit, right? I don't know how many environments that I've personally pen tested where I've seen basically a flat network design, right? Where all systems, workstations, production, everything are just all inside the corporate network. And obviously that's not recommended. But companies that are startups or are really focused on growth or haven't really had an IT background or cybersecurity background, maybe they just had a friend start their IT systems and they really didn't design it from the ground up the way they should have. So, what's going to happen, right? If people aren't coming into offices, that means they're not inside that hard perimeter, right? But, they still got data and they still got to do work, right? And, businesses are going to fight to stay alive, right? Businesses don't want to go out of business. People have sunk a lot of time and money into these entities, and they want them to continue to thrive, right? So they're just going to get work done any way they can. And I think that's going to be a lot more of work occurring on not corporate owned devices, or a lot more work occurring just on whatever you can get your hands on, right? Which means, there's going to be more and more breaches outside of this perimeter. And if we don't come up with a good way to get visibility into those endpoints or protections around bring your own device and other type policies, that's going to be a huge problem. And it'll be interesting to see how this plays out. Obviously companies could still, mail equipment to employees, but if you're trying to make a decision between buying new laptops and making payroll, obviously you're going to do payroll and tell people to use their own computers, right? So So I mean, businesses, I mean, a lot of businesses, especially small businesses, are going to be really hurt by the market downturn, right? So, you know, personally, I think zero trust. I mean, this is going to be the way of the future, man. I mean, a lot of companies have already started implementing this, and you know, implementations versus different companies widely vary, right? So, just saying because you do zero trust, that may be great or it may be useless, right? Depending on your implementation. So I think, you know, the real thing here is with zero trust design, you're basically, you know, you're going to authenticate who the user is that's sitting at the device. And then you're also going to authenticate the device, say like, hey, does this device good to like access our corporate resources? And, you know, that could be like, you know, is this device owned by us? Or that could be like, does this device just like meet our requirements? Like, does it have antivirus on it? You know, has it been patched? Things like that. You know, and if you haven't met those requirements, you can't verify who you are, or the device doesn't meet the corporate policies, then zero trust just basically says like, hey, you can't talk to anything in our enterprise, right? But if you do, then the zero trust systems will enable you to talk just to the systems that you're allowed to talk to, the systems that are inside your kind of like group, right? So, and then another nice thing about this is you kind of have these central points where you can audit who's accessing what systems from which devices. So, you know, that's a lot better than a flat network for multiple reasons, right? You know, if one workstation gets compromised in a flat network, generally attackers will try and move laterally onto, you know, other workstations, right? Until they find a workstation that has, you know, someone doing admin tasks inside the network. Right? In a zero trust network, you can really only talk to the applications that you're allowed to talk to, which means you can't really talk to any other workstations, ideally. And if you can't talk to other workstations, then that makes attackers' life a lot more difficult because they have to find a vulnerability in the applications you're talking to, and then wait for other users to log into those applications, and then they have to have a capability then to move downstream from those compromised applications to other workstations, and then kind of like move up and down. That's a lot more complex, right? So, and a lot of attackers are not trained on that. You don't see, you know, a lot of hacking groups or even red teams or pen testers really taking the time or effort to go through that work. You know, you might see it in limited scenarios, but you know, that might be something also to watch. It's just kind of the way that attackers are going to try and move through the networks more and more in the future, right? You could definitely, you know, get a zero trust type system going low cost, you know, by implementing, well, you get some of the features by implementing host-based firewalls across your enterprise. You know, just even something as simple as, you know, making sure that hosts can't talk to other hosts' SMB services on like, you know, port 445. Then, you know, that can be quite effective where you have maybe like a CIDR block that can talk out where the admins reside, and everybody else can't talk to each other, because that just makes lateral movement that much harder on the attacker side. So yeah, yeah. So I mean, zero trust is a big thing. It was really, I think, pioneered at Google. They have a big write-up on it, and now there's several vendors that have taken it and commoditized it, so to make it easier to implement at your organization. You know, I don't have a specific vendor recommendation, but I definitely think, you know, as more people turn to remote work, and just honestly, this is something that we should have been doing a long time ago to make the inside of the M&M a lot harder, right? So, in addition, right, you know, if you're not really going to the office anymore, you're probably not going to really care if your servers are at the office, right? So I feel like, and this is already kind of a trend, you know, there's going to be more and more focus on cloud security. The border that used to exist because people are going into office spaces and you could have site-to-site VPNs between offices and all that stuff, you know, that's really going to diminish even more now that more people are doing remote work and whatnot. Make sure you can force everyone to VPN into the corporate LAN and things like that, but seems far more effective to have your systems built around a cloud security model. I mean, there's some pros to the cloud security model. One of them that I like is things are a lot more audible. Like there's an API you can call to find out how many servers you have, right? Or how many files you have in S3 buckets and things like that. Things that are typically quite hard to figure out in a traditional data center model where people install devices in data centers. They're supposed to be tracked in some type of asset tracking system, and everyone who's in this industry and does it long enough knows for the most part, those asset tracking systems are pretty inaccurate, right? So, people try and create like a master CMDB of their assets in their enterprise, but I feel like that's still executed very, very poorly. One of the downsides of cloud accounts is just if there's cloud accounts sitting out there that you don't know about, obviously if you don't know about them, you can't monitor them, you can't enable auditing and logging and all that. Another downfall of cloud is a lot of people think like, I'm going to push all my resources to cloud, so I don't got to worry about that. That's Microsoft's problem, or that's Amazon's problem. And in reality, the bulk of the security work still sits on your shoulders, right? So the way that you configure the policies and roles and permissions in your cloud providers is mission critical. I mean, I don't know if you guys have looked for, cloud storage breaches on a Google search, or like S3 storage bucket breaches, but it feels like every month there's like a major breach, right? Like Time Warner Cable, DGI, the Army, Accenture. I mean, they all left tons of files and in storage accounts on these cloud providers that were just open to anybody on the internet. Anybody on the internet could have gone and downloaded them. There is a project, it's called Gray Hat Warfare, where this guy has actually gone and indexed all the files which you can find in public storage accounts on Amazon, so you can search them in real time. So it's kind of like a showdown, but even more intrusive because you're like searching people's files or file names, and then you could go pull the contents, right? So I know that's like kind of questionable ethics, right? I don't know where that lies. I mean, definitely when you start accessing someone else's data, you don't have authorization to access, even if there's no restrictions placed on it. I feel like that's illegal, but I'm not an attorney, so don't take legal advice from me. It's pretty crazy, right? But this is the new, right? I mean, data centers are pretty expensive to run, it made some sense when you already had the connections and facilities set up, but as more and more of these office spaces, if they go away, or we move more to remote work, definitely these cloud services are just going to become very standard in our industry. All right, so here's the other thing that I was kind of thinking when I was thinking up hey, if everyone moves to remote work and we stay away from each other all the time, which sounds fabulous to me, what are attackers going to do? How are they going to change how they're going to come after our infrastructure? And one thing that I think is going to get even more prevalent, I mean, this is already popular now among attackers, but if I'm pushing all my stuff to cloud and I have zero trust, going after your corporate LAN and all that's going to be hard, man. I mean, it's just going to be, it's not like it's not possible in a zero trust model, but it's a pain. So an easier way would be, hey, if you as a company trust another company, because almost every company out there has vendors, they need something to do their job, right? And then a lot of those vendors have higher privilege access inside of their environments because they need to be able to talk to their other systems, and they need to be able to put orders in or make requests, things like that. I think we're going to see more and more actors target these third-party vendors. Even though they maybe don't care about those vendors, they really want who those vendors provide services to. There's been a lot of reports lately about MSPs, like managed service providers, being compromised, and allegedly by nation state governments, and then they're using that as initial access into the MSP's clients, right? Like the MSPs that they're monitoring for either availability or security concerns have an agent, and then the third-party MSP provider is able to monitor and fix problems on those endpoints. And so the attackers go after the MSP because once they get access to one MSP, they can access a multitude of target environments. And maybe they don't care about all those, but maybe they care about one or two. And so for them, that's good value. So I'm just calling this deep phishing, right? Because I'm trying to come up with a term, right? And you know, this is not like a theoretical, right? This has been done, right? And it's probably being done right as we speak. So, for example, the whole Target scenario, right? The way that they got a foothold into Target systems is that they went after basically a vendor or supplier for Target, right? They fished onto that guy's laptop. They got his creds, and they used his creds as initial access point to start talking to Target systems directly. And then they were able to, you know, gain access to those systems by chaining together a series of vulnerabilities, which then allowed them to pivot around the network and eventually get to the point of sale terminals, where they started stealing credit card numbers at all of Target's locations. You know, and they exfilled the data and the credit card numbers and all that stuff, right? So I mean, you know, this is not might happen. This is happening and will probably dramatically go up if things continue down the same path. So I think, you know, one thing that we're probably already experiencing right now is as we're sitting at home, because we're forced to be home, we're going to start using the internet more, right? I mean, if your boss or coworker isn't sitting right next to you, I mean, there's a lot of employees that are going to just open up Netflix or whatever and start watching stuff from their house while they're working. And not saying anything bad about that, just saying, you know, that's more bandwidth, right? And you know, the more we're forced to be at home, the more we're forced to use the internet to interact with each other. And the more we use the internet, yeah, the more traffic that goes across it. Large tech companies, Facebook, Google, Microsoft, AWS, Azure, they've already invested heavily in these undersea cables, right? These fiber optic cables to connect their data centers around the globe so that they can provide the best experience to the users on their platforms. So I think, you know, we're going to see significantly more internet infrastructure go down in the next few years, just due to demand for remote work and bandwidth requirements. You know, it'd be interesting to see whether the last mile, like the internet providers to us, actually step up or not. You know, but you know, these major tech companies, they need these type of services to continue to provide, you know, continue to be competitive in the space. So I think that's cool. I mean, you know, that's a better internet ecosystem for all of us, right? But you know, with that, I really think that there's going to be even more of a push for end-to-end encryption, right? I mean, the more cables that go down, the harder it is to monitor the cables to know what's going on at all your different locations. And you know, companies like in the tech industry, like Facebook, have been preaching for a while now that, you know, you need to do end-to-end encryption everywhere, like even inside of your private networks in your data centers, from application to application inside your own data centers, you need to be encrypting it. And that is what, as far as my understanding, my knowledge base, is what Facebook does right now, is they encrypt all the transmissions even inside their data centers. So even if someone were to compromise one of these fiber optic cables, or they were to compromise a switch or a router in a data center, they theoretically would be unable to read the communications because they're encrypted even inside their own private networks. So I think that's pretty cool. And I also think the push to cloud is really enabling this. I mean, the cloud providers basically enable TLS automatically because they assume that you're going to access them over the internet, which is not trusted, but you don't have to. I mean, there's ways to set up AWS accounts that are completely private so that none of the services that you're using can ever talk to the internet. You can drop endpoints inside of virtual private networks in AWS, and you can set up a lot of those services now so they never talk out to the internet, right? But you still, I mean, that's inside AWS's data center. So you still want, what if a router or switch gets compromised in their data center, right? You want that to still be encrypted, and a lot of those service providers are now doing that by default. So I think you'll see more and more push for this. You know, I know some of the major tech companies are doing this now, but not all big tech companies are doing it. Just really the ones that are trying to be a little more proactive. So hopefully, you know, everybody just does this by default going forward. So, or everyone gets on the cloud providers, and the cloud providers are just kind of doing that transparently underneath, right, for you. All right, so yeah, deepfakes. Deepfakes are scary, man, right? Because, you know, at least right now or previously, you know, if something was a fake, you know, journalists would really be all over that. I mean, up until lately, we've still had press conferences with the president, and journalists were invited to be there. You know, we're kind of going into at least for me, an unknown territory here. You know, if we can't meet with people in real life, there's really no journalist or anyone to fact check that someone said or did something, right? And if somebody's able to create videos and to the point in which we can't detect that they're fakes, I mean, you know, they could potentially shape world events. So for example, I mean, it's widely considered to be a fact now that, you know, foreign governments were meddling in our previous election, right? And I mean, my understanding of reading the unclassified reports about this is that, you know, Russia basically wanted to sway the public. And so they used the ad networks and fake accounts on providers like Facebook and Twitter and things like that to try and push certain narratives. And they thought the net effect of pushing those narratives would be that, you know, you would vote more for one candidate versus another candidate. So thinking about this again, we've got an election theoretically coming up in 2020 if it doesn't get postponed or whatever they're going to do, right? And, you know, what if Russia produces deep fake videos that we can't, using technologies we can't verify are fake, and then just starts releasing those on social media, which starts swaying the public one way or another, right? I mean, that's a pretty, you know, maybe we have the technology to detect those fakes now, but, you know, technology has a way of leapfrogging to, in a way that, you know, improving in leaps, right? So, you know, it's possible. Is it probable? I don't know. But you know, without people being at press conferences or being able to fact check with people in real life, I mean, that definitely makes, you know, trying to manipulate public opinion like a whole new level. Yeah, it'll be interesting. See what happens here. I mean, there's definitely, you know, incentive, right, for foreign governments to meddle with other governments' elections, right? So. All right. Okay, great. So, you know, I think one thing that might be positive is, you know, I don't know how many of you have VR sets, virtual reality sets, right? You know, if people start to lack the human interactions, right? I mean, this is an alternative that they could go to with little risk, right? Without the risk of catching the virus or anything like that, you know, as long as they're not sharing headsets or something with people, unknown people. But you know, this could be a real boon to this industry. I mean, the VR industry is, in my opinion, pretty cool. But you know, it's still, you know, pretty enthusiast space, right? Like people who want to be into it are into it. You know, that we could see like a much wider, especially if like the virus were to linger for like a year and a half or something, like some people are predicting. I mean, you could see a boom in VR. I mean, right now, you know, you could go get theoretically like an Oculus Quest, and you don't even need a computer to hook it up, and you can do room space-based VR. You know, you don't even need a good computer, right, to run it. It's all self-contained in the headset, and you don't even need sensors on the walls or anything fancy. You just plop this thing on, pick up the controllers, and you're good to go. So, I mean, we could see that stuff start to boom, right? And, you know, I know there's some like applications on the platforms right now to do social interaction. I've looked at them quite a bit. You know, I'd still say they're pretty basic, right? You know, there's some VR chat room like experiences that are, you know, people like, but you know, they're still pretty, in my opinion, rudimentary. So you could see a lot more app dev time being put on those to provide people with a much better like experience, right? So instead of this just going from an enthusiast market that people think is going to be a thing in the future, you know, it could be a thing almost now, right? So, right. So then I was thinking like, VR takes off, right? Theoretically, because people can't go outside for like a year or something like that. I mean, that's, you know, probably a worst case scenario, but I was just, you know, go with that scenario. So I was trying to think like, hey, what's the implications here, right? And like the thing that you're gonna have all these guys developing VR apps, right, for this platform if it takes off. And historically, I think that's gonna be a lot of the same resources that have done video game programming in the past. And video game programming in the past is not it's been very emphasis on features and performance, and there hasn't been a huge emphasis on security, right? So at least from my perspective, there has not. So like, for example, yeah, I mean, several vulnerabilities have been discovered in video games. Like a lot of the games on Steam that are produced by Valve used to use or still use the source engine, like CSGO uses it, and I believe Team Fortress 2 uses it and all that. And, I think there was a period of time where for like, I don't like, let's see, like for about 5 years where there was a particular spray, in those games you go around and tag the walls, right? And if you tag the walls, you can have your team's logo and stuff like that on the walls, right? So, you could kind of use that to mock the other team as you're winning or whatever. But for the period of 5 years, there was actually a vulnerability where if you built a very, like a malicious spray, you could spray the walls and basically crash everybody's clients except for your team's. If your team's clients don't crash and everybody else's does, you can go around and frag them. And eventually a German researcher reported this vulnerability to Valve, and they fixed it across the platform. But, there's things like that I feel like the gaming industry has not really put a lot of time and effort on the security end. So what could this future look like? If they're going to crank out a bunch of code, they're going to crank it out fast, and they haven't really been focused on security in the past. What's that going to look like in the future? And one thing that I just kind of thought of was, this could literally be, a whole new market, right? So I don't know if you guys are aware or not, but there's companies out there right now, and all they do is they buy zero-day vulnerabilities or zero-day exploits, right? And what is a zero-day exploit? It's an exploit that takes advantage of a vulnerability in a piece of software that that's not known by most people, right? It's known by you, but not really known by anybody else. So then you can sell that exploit to somebody else, and that usually gives them some type of capability, like lets them bypass authentication on an application, or gives them remote code execution, which means they can execute whatever code they want on your system. And if they can execute whatever code they want on your system, they can steal your files, or they can, use your system to pivot to other systems, or they can, just generally do anything that you could do on the system, right? So right now, it's pretty baby town frolics if you want to develop exploits on gaming platforms. So it's not that hard. But if everyone starts using VR, and VR is using a lot of the same code base that gaming software is using today, the value of these exploits for the VR platforms could go high, right? And now, one possible use case for this is, I don't know if you guys have ever seen Ghost in the Shell before or not, but there's a hacker in here called the Laughing Man. And basically everyone in this basically futuristic society has enhancements, right? Like some part of your body is enhanced with technology. And so he is such a good hacker that he's able to exploit weaknesses in those enhancements so that no one could ever see his face. So every time everyone tries to see his face, they just see this Laughing Man logo, because he basically has O-days for their enhancements, right? So, you could see something like that occur so that people could stay anonymous on those platforms. If everything's flowing through the internet and everybody's on, 1 to 2 to 3 major chat platforms on VR, chances are high, criminals and others are going to jump on there, which means law enforcement's going to jump on there and start monitoring it, right? And, there's always a sub-demographic that wants to stay anonymous on the platform. So, that's one use case. Another use case is, if people are actually able to develop exploits for those platforms, maybe they can even get remote code execution on your laptop or something like that. So it's like, hey man, let's meet up on VR and chat. And when they do, you take advantage of a vulnerability in the software and you're able to take control of their laptop without them knowing. So, you know, it's pretty interesting just how a remote work shift and how getting rid of a lot of this old, you know, hard outside, soft inside type mentality would, you know, would change us. But in the cybersecurity space, I feel like, you know, a lot of parts of society is maybe not for the better, right? But in the cybersecurity space, I feel like there's a lot of stuff that we should already be doing today. So even if like we all wake up tomorrow and like CDC's like pandemic's over, like we're all good, everybody go outside, I still feel like a lot of these recommendations here in these presentations are things we should be doing, like zero trust, cloud security, right? Those type things, end-to-end encryption. I mean, those are things regardless of what the future holds. I mean, we should really be pushing organizations towards those type of solutions. And as cybersecurity professionals, you know, if we should be making these things dead easy for corporations to implement, right? I mean, one thing that is really annoying to me is just, you know, like a company, their goal is to stay in business, right? It's to like drive value to basically, you know, their clients and their shareholders and all that, right? And I feel like historically, a lot of cybersecurity professionals, they're the no guy, right? They're kind of like the mom that goes around the organization. It's like, no, you can't do that. You can't do that. You can't do that. And really, as an industry, we need to shift from no, you can't do that to, yeah, you can totally do that. And here's how we do it in a way that is, you know, well organized for you and well organized for us as security professionals. So, you know, we don't want to be the guys that are just telling people no. I do believe the push to cloud is from, you know, for most of commercial is inevitable, right? It's due to the cost savings. But the, you know, as security professionals, it's on us to go learn those platforms, right? We can't just be like, hey, I know firewalls, I know VPNs, I've been doing this stuff for like the last decade. I'm not gonna learn cloud. Like that's like I don't need to know how roles or access control works in cloud. Like it's not gonna be a viable strategy in my opinion for the next 20 years, right? So as on-prem and data centers start to dwindle, that stuff's all gonna get migrated to cloud. As you know, startups, most of the startups are turning to cloud infrastructure just due to their need to start cheap and small and then scale up rapidly with their platforms. And, you know, I do think the serverless platforms that are on cloud right now are okay for basic tasks like scripts that you want to automate, but, you know, they're pretty hard for advanced applications because it's hard to debug the code in serverless environments, especially if you have like multiple serverless components all talking to each other. It's hard to know where things are failing, at least for me when I'm developing things in Lambda and those platforms. So I mean, I do think that there still needs to be a little more innovation and ease of use in the serverless space, but I do think that's coming as well, right? So containers are kind of the new, and orchestration of them. Kubernetes is clearly the winner of that right now, which, you know, a lot of the cloud providers have very slick managed service for right now. But, you know, after that push is over, then I think a lot of people are going to turn to the serverless, and hopefully it'll be mature enough by then that people will actually be able to debug complex applications in those ecosystems. So yeah, so I think as security professionals, we just really need to get ahead of the curve, right? We can't, you know, just keep saying no forever. We got to be the guys that know the cloud. We got to know AWS, Azure, GCP. We got to know zero trust, right? We got to know how to take these old legacy lands and easily get them into a more secure state. And then we got to be innovating, right? Like it's not good enough for us to just say like, hey, you know, yeah, everyone just gets pwned by phishing, you know, and it's not good enough for us to say like, you know, we just need to do more user training and awareness. Like that's not a real solution, right? Like we need an actual solution that we can provide to the masses and be like, hey, we know you guys get phished, install this solution, and, you know, that mitigates 90% of the risk or something like that, right? And, you know, a lot of that work is still to be done. So that's the great part about cybersecurity as a profession. And in my personal opinion is just that, I mean, it's still a little wild westy, right? There's still a lot of opportunity out there. And, you know, while it's horrible that we're all focused to stay inside, I mean, some people think that, right? I mean, this is a real opportunity for us as cybersecurity professionals to try and push forward the industry, and yeah, and try and make this just a little bit better of a world than it was yesterday. So I should leave that with you guys at this time, and we will. I think that's the last slide. Oh, thanks again on the sponsors. Really appreciate it, especially DigiSer is so helpful every year, and RSA and Adobe. And Mimecast and Corelight came through this year, and Red Canary and SaltStack, and even SaintCon and No Starch Press and Redpoint Security pitched in as well. So I really appreciate all them and all they're doing for this event. So with that, and I will post the slides that I just had onto Twitter. My Twitter name is TweakFox, and I'll put it in this chat. Also, I will, these are being recorded and they should be up on YouTube relatively quickly after the event. So big thanks to, once again, to Pope with Pope Tech. Really, this event would not be happening without Pope and the team, right, and his media team. So I really want to thank them again. They, in a matter of basically a week, put this entire thing together from a tech stack, and hopefully we won't have any issues with recording and all that, and everything will be up pretty rapidly. So, all right, we will have the next session at 2 p.m. It'll begin. I'm just gonna answer these random questions in the channel for a minute while we're waiting on that. So why is it called B-Sides? My understanding of why it's called B-Sides is because if you guys remember tape decks, they had two sides, right? So the primary side, when you had a tape and you put it in the tape deck to play music, would be the A side. But then a lot of artists realized they could record another stream on the tape deck on the back side, and they'd call that the B side. So that's kind of where the name came from. And I think the implementation there is really, Black Hat in Las Vegas is I don't have anything bad to say about it. I think it's a great event, but it's also very expensive, right? I mean, tickets are basically $2,000 a pop, which makes the event very inaccessible to a lot of audiences, right? I mean, unless you have a corporate sponsor, you're probably not going to pay $2,000 to go to Black Hat. And so, some of the original organizers where B-Sides started in B-Sides Las Vegas, they were just kind of like, hey, we need an alternative here that's low cost that everybody can go to. And so they created B-Sides, LV, or Las Vegas. And, that comes from the reference to the tape deck, right? So, the A sides may be Black Hat, and then the B side is their conference, the alternative that everybody can go to. So, yeah, so that's kind of where the term comes from. And then they kind of put together like an ethos, right? Of like, what is a B-Sides? And then the organizers in B-Sides San Francisco, which is one of the larger B-Sides events, B-Sides Las Vegas and B-Sides San Francisco are pretty large. They, got a trademark around the term and kind of put some legal framework in there. But every B-Sides is its own legal entity. So like we are, and some of them go through the process of becoming a nonprofit. So B-Sides Las Vegas, or no, B-Sides Salt Lake City, we've gone through the process of becoming a nonprofit. We're a 501c3. That's really thanks to the work of one of the board members, Ryan Simpkins. He basically single-handedly did that for us, which I completely, my hat's off to him. I owe him, and he helps us make sure we're compliant with state and federal laws with the charity every year. So just know when you buy a ticket or you sponsor the conference or anything like that, your money is going to the nonprofit. I don't, no one who spends their time and effort on the event makes money off the event. And then the only thing we do with the leftover funds is we use that to seed the next year's event. So my goal really is to make this a self-sustaining event, right? Where we have enough money to keep growing it every year. I could envision a future where, there's thousands of people at a B-side Salt Lake City event, right? I mean, at a $20 price point, I don't think that's unreasonable at all. I think there's something to be said about making the event the way it's been, which is more small and intimate, which, we're trying really hard to stay true to our values when we originally created this. And really, if you haven't heard I think my speech is recorded on YouTube on the channel from 2 years ago about like why we're doing this. But the reason that we're doing this is, I don't know if you've seen in some of my emails, but the slogans, by the people, for the people. I mean, my goal really here is for number one, to get more people into cybersecurity. I really like to get more college kids coming out to the events and up to speed, and just even if they like have a little interest but they're not certain, give them a platform to make some more connections in the community and kind of build their social network a bit more. And then two, if you're already in the community and your cybersecurity platform professional, this gives you a platform to give back to the community. So I really encourage people that are professionals like to submit for the workshops and the villages and the call for papers next year, especially if you're in Utah, because like I just want more of the college kids to see and get to know professionals in the industry, and kind of have more of a vision like, hey, if I work hard, I could be like this guy, or I could be like that guy. I could I could be, and in the process have fun. Like I could do some like RFID hacking, or I can learn a bunch of cool content at these talks, and then hopefully inspire them to go down, become cybersecurity professionals themselves. So and then hopefully that grows the whole community across the world, right? So even if they don't stay in Utah, if they move to DC or anywhere else, then we're still doing our part to kind of at least help meet the cybersecurity gap a bit more, and also one of the primary things here is give back, right? So I think a lot of us who are in cybersecurity now and have, the things that we have in life, we got here because somebody was willing to take the time out of their day to, to talk to us, right? I mean, I know personally when I was growing up, I used to meet up with a bunch of hackers at a round table pizza like every week, and we just talk about computer stuff. And that was pretty much the catalyst that gave me the ability to get into this industry and to hopefully make a positive impact. So all right, so I'm going to hand it off to the next speaker, who will start in 4 minutes now. Thank you guys. If you want to chat more, I am on Slack. I'm Bryce Coons on the B-Sides. And if you guys need anything, feel free to email info@bsidessaltlakecity.org, and someone on the team will get back to you. Thanks, guys.
Hey guys, can I get a confirmation if my screen is visible and that I am audible?
Yeah, your screen is visible and you are audible. You're good to go.
Awesome. Awesome. Sounds good. So welcome everybody to my talk. I am happy to meet you guys virtually. Welcome to my talk, Where's My Dough? A look at web skimming attacks on e-commerce websites. So before I get started, I want to give you a brief introduction about myself. I'm a senior product security engineer at Salesforce. I specifically work on the Commerce Cloud product for Salesforce. Prior to Salesforce, I used to do a lot of pen testing, threat modeling, and code review. And I was in consulting, part of Aspect Security and EY. I go by the Clumsy Coder on Twitter, so I'm available on the interwebs if you ever want to catch up to me. The agenda of this talk is to give you a brief overview of web skimmers, what they are, the information they are after, e-commerce sites they have manifested in, known hacker groups, that's MageCard, some web skimmer characteristics, such as how do they detect payment forms, how do they exfiltrate data, some of the anti-analysis features we've seen manifested in these skimmers, and then dive into a little bit of the mitigation strategies that we want to enforce to avoid web skimmers from doing what they do today. So before we jump into it, I want to talk about what we're looking at in this talk. We're looking at the e-commerce platform, and just to give you a lay of the land, an e-commerce platform is something that's providing the infrastructure and a reference architecture for merchants to build their storefronts on and kind of build their website on. And then you have partners that collaborate with the e-commerce platform to write plugins and extensions over your e-commerce platform that your merchants can use. For example, order management plugins, checkout plugin, and so on. So let's look at a typical online shopping process and how a web skimming attack works in the context of an online shopping process. So a user visits a website, an e-commerce website, enters their credentials to log in. The user likes a product, so they move that product onto a shopping cart. Immediately, they move to a checkout page where they get to fill in their credit card information. And in that checkout page, unknowing to the shopper, a malicious script executes there, collects the credit card information and manages to exfiltrate that information before the order is placed. Now, sometimes this is, of course, unknown to the user. Sometimes it is also undetected by website maintainers or site administrators as well. Let's dive into some of the how web skimming actually started and some of the origins of web skimming. It started in early 2014 and in 2015 when a bunch of hackers started attacking Magento-based e-commerce websites. They were specifically looking for admin consoles that were exposed or arbitrary file upload vulnerabilities through like CSRF. And they targeted these admins to upload these web skimming codes specifically in locations or in pages that were involved with the shopping cart. And as you can see, these were all under the Mage folder, and that's why threat intelligence teams that were tracking these hacker groups started calling it MageCard, and that's where the name stands today. So how were these hackers getting in? They were relying on underlying vulnerabilities in operating systems, exposed services like FTP, SSH, applications, admin consoles, vulnerabilities in web application code, third-party libraries hosted on the site's infrastructure, third-party libraries hosted on CDNs, and also third-party plugins or extensions that were part of the e-commerce ecosystem. Fast forward to 2020, we've all seen in the news big incidents related to web skimming attacks, namely Ticketmaster, which was a huge supply chain attack where the MageCart managed to compromise a third-party service called Inventa. British Airways, where they managed to compromise the web server itself and host their malicious script. They hosted it in a script that would look very common to any web application that would rely on, like Modernizer.js. Newegg, where they again hosted a malicious script directly on the checkout page. And then you had Macy's, where the malicious script was added to the payment and the account profile pages as well. Let's look at an example of the skimmer that was manifested in the British Airways situation. You can see it's a simple and elegant web skimmer code of just 22 lines of code. Here you see that there is an event of mouse up and touch end that is binded to the submit button of the checkout page. So here, with just the mouse up and touch end, you observe that this was not just targeted for like a web-based application or a shopper going to a browser, but also the touch end indicates that it was also targeted to shoppers that are shopping using the mobile app as well. So this was a very well-crafted attack by MageCart, and they knew exactly what endpoints the application is calling, and they had done a lot of recon before they actually targeted British Airways. The other thing that I want you to make note of here is that the exfiltration URL, the exfiltration is happening via an AJAX call, and it's happening to bawage.com. Now, another thing to call out here is that they have spun up an infrastructure that mimics the infrastructure of British Airways. So anyone auditing the traffic would assume that BA-Ways is part of the British Airways infrastructure as well. Thus, they get to be persistent on the server and exfiltrate as much as credit card informations they want, as long as a site administrator manages to call that out. Similarly, we see what happened in the case of Neweggs as well, where an elegant just 15 lines of web skimmer code was added. Here we're able to see that it is the same group of MageCart because they use the mouse up and touch end technique, targeting not just web browsers, but also mobile apps. And again, they are using the infrastructure that mimics Newegg and spun up a whole new infrastructure that is very similar to Newegg to kind of get all that data off from their servers to their C2 domains. Now, based on the targets that these hacker groups attack, based on the volume of credit cards they get, based on the skimmer characteristics and the infrastructure setup, threat intel groups have managed to profile them into 7 groups. Groups 1, 2, and 3 relatively go for small size to medium sized storefronts and compromising anywhere between 2,000 to 800,000 victims. They use the same domain that hosts the script that is also used to exfil the data. Now, whereas group 4 to group 7 starts getting a little more advanced. Group 4 goes after high value targets. They usually go for thousands and thousands of credit cards. Their skimmers also have a self-cleaning ability or anti-analysis features to them. We will walk through one of such examples as well. They also have complex infrastructure and their exfiltration or C2s look more like ad domains, CDNs, and analytics that you would be used to seeing. Group 5 comprises of groups that go again at high value targets. They go for, again, thousands of credit cards in bulk. And they also look at third-party domains that the target domain relies on to compromise that third party does get a foothold into the major or the exact target they are after. Group 6 is the one that I showed an example of a skimmer in the previous slide. These are the groups that go again for high value targets like British Airways and Newegg. They directly inject the skimmer into the payment and checkout pages. They write very simple skimmers, usually between 10 to 20 lines, and compatible with both mobile and web as well. The seventh one is also very notorious because they use proxy exfiltration domains, and these domains actually belong to legitimate organizations. So it gets even more harder to kind of take down these domains as well. So let's look at some of the web skimmer characteristics. Over the years, these hackers, this hacker group has matured, and they are getting very sophisticated in their skimming technology. And more often than not, it is now starting to look like banking malware, where it has a layer of obfuscation. It has some kind of page or form detection. It has information collection and storage mechanisms, wherein a multi-page checkout, the skimmer manages to detect that and then store the user information in the local storage of the browser. Data exfiltration techniques, they manage to mimic the infrastructure of their target. They manage to exfiltrate data using a get image, which we will be walking through. And then also a lot of anti-analysis technique where they detect whether an auditor is actually looking at the source code, detecting whether the user is in debug mode and does self-cleaning or erasing their skimmer code. So web skimmer obfuscation techniques, right? So the main purpose of obfuscation is the action of making something less clear and less easy to understand, especially intentionally. So the obfuscations that you'd commonly see when it comes to these groups is name-based obfuscation, code flow obfuscation, dead code insertions, string encryption, minifications, and compressions. So everything to make it difficult for anyone auditing the code to see what's happening. Let's look at group 7's skimmer characteristics specifically. So group 7's skimmers are highly configurable. They not just allow you to just set the target domain name, but also let you configure the exfiltration or the proxy domains that you want to send the exfiltrated data to. So that's what you see here, and these two parameters or these two attributes here or variables here. This is the skimmer code, and it's relatively simple to go through. The skimmer is simple in that it will check if a certain element ID check step review is displayed, ensuring the victim has reviewed the products they are paying for, reviewed the shipping details, and finally filled out the payment information. If the form is active and populated, the skimmer will go through the individual form fields to grab the information. At the end, all the stolen data is concatenated into one string, with each data separated with a pipe symbol encoded into base 64 and prepared for URL encoding. Now, after the data is encoded, after the data is extracted and turned into a large data blob, the exfiltration starts. The exfiltration of the data is done in the form of a GET request instead of a POST request. The skimmer creates two image elements, and which then get their source URLs set to the compromised websites used for proxying. The encoded stolen data is appended to the URL along with the host name of the store the data actually came from. So you can see that here. So some of the skimmers also have anti-analysis techniques. And in this example, we see that it is using the debugger keyword. And if there is anyone auditing a checkout page that actually has the skimmer embedded in it, uh, they would actually end up opening the browser's developer tools. And if the developer tool encounters the debugger keyword, the execution of that page would actually stop, and it would expect the user would actually resume the control flow of the program. Now, what the skimmer does here is it makes note of the date, and it makes note of the times and calculates the the difference in the time. If it is greater than a predefined offset, it sets the is debugging true, and this informs the skimmer to kind of delete itself from that DOM or from that page. So these are some of the techniques that these groups are now starting to use to kind of evade detection and being audited as well. There are also steganography-based skimmers. So how often do we go to a e-commerce site and we see a label like this on a checkout page, right? There are ways in which the hackers have managed to even embed. The hackers have managed to embed skimmer code in these images as well. So if I were to run strings on this image, we'd see that this image starts off with a regular JPEG or JPG file. And then at one location, it starts actually with JavaScript code. And you'd now ask how this JavaScript code is actually executed in the context of the checkout page. And turns out there is a JavaScript API call that's specially Slice. It's called Slice, where it extracts the code from that position and invokes it as a function, and thus running the skimmer on that page and allowing it to get do what the skimmer does and exfiltrate credit card information. WebSockets. This is one thing that we've never thought of that could be used for web skimming, but turns out the hackers have managed to even use WebSockets as well. So if anyone's using WebSockets and we want to audit and see how this WebSocket was actually initiated, we'd actually try to search for a WebSocket initialization in that page. But this is a very nice, nicely obfuscated obfuscation technique that the hackers have used here. They have managed to cleverly hide the skimmer loader by using a CSS class to construct the WebSocket URL. And that's what you see here. This is the origin WebSocket call that this is the actual code that creates and reaches out to the server using WebSockets. And this is the actual routine that uses the CSS to kind of construct the WebSocket URL. Once the WebSocket URL is created, it reaches out to the attacker's domain, and the attacker's domain keeps sending some benign responses until it sees the checkout in the URL. Once it sees the checkout keyword in the URL, it actually sends the main web skimming data back to the checkout page, which executes in the context of the DOM and does everything the skimmer would do to exfiltrate data from the target domain. So now that we know what we're against, what can we do to protect, especially from an e-commerce standpoint? An e-commerce platform manages hundreds to thousands of storefronts. So what can an e-commerce platform provide to the merchants to make their storefronts more secure? So, and there is no silver bullet here. The solution is going to lie between on the collaboration of the merchants, the e-commerce platforms, and the partners combined. So let's walk through some of the mitigation strategies that an e-commerce platform can provide to begin with. E-commerce platform can enforce two-factor authentication across all merchant site administrators and developers, harden server operating systems, reduce the attack surface by minimizing the exposure of services like SFTP and SSH, provide secure by default configurations. So if the merchant spins up a new storefront, we need the e-commerce platform should always provide it over HTTPS and provide configurations to communicate over secure ciphers, for example. Update developer documentations to reflect security best practices for reference architectures for the merchants, so that they always start with a secure state when they use a default spun up storefront provided by the e-commerce platform. Perform secure code reviews of partner code extensions, because we're seeing a lot of these hacker groups now target partner code vulnerabilities in the partner code to kind of compromise the merchant storefronts. So perform secure code reviews of all of those extensions that the e-commerce platform maintains in their marketplace. Sub-resource integrity. This is a very, very common approach to kind of stopping execution of malicious scripts in your website or your domain. So say you have the myshop.com and it requests a site, and the site loads a JavaScript from some CDN.com. Having a copy or the integrity, using the integrity attribute in the client side would be very beneficial, because the browser would already have the hash or the message digest of the script that was requested. Once the script is downloaded onto the client, the browser now calculates the message digest and compares it with the message digest that was already in the client. If it matches, it executes the script, or else it will not allow the script to be executed. So what happens if a web skimmer is actually present in a script from some CDN? In this case, the hashes would not match, and the browser would not allow the skimmer to be executed, and thus the data will definitely not be exfiltrated to the attacker's domain. So sub-resource integrity is a very good friend for when it comes to checking the integrity of the scripts that we run in our domains. And this is the general error message that you would see on your browser when a sub-resource integrity check fails. Some SRI considerations: it is a trust but verify approach. Well-known CDNs support this today, and they provide you a hash with corresponding version values of each script that you want to use in your domain. Update the sub-resource integrity attributes when scripts are updated. It's very important to do that, or else it might break functionalities in your website. Integrity attributes can also be applied to CSS, so you might want to consider something like that. And partners that develop extensions for e-commerce platforms must also now include SRIs. And this is something that an e-commerce platform can start holding to partners to start enforcing SRIs in every script in their extensions as well. And partners must also now maintain and make available the extension versions and the corresponding hashes as they maintain their third-party code and provide them for merchants to integrate in their storefronts. Again, sub-resource integrity is almost supported by all browsers today. It's been there and it's very reliable. The next one is content security policy, and this has traditionally been used to mitigate cross-site scripting vulnerability attacks or cross-site scripting attacks by whitelisting sources of script, style, and other resources. And this is exactly what a typical content security policy would look like for a site. So default, it would allow any resources to load in that domain. Script source can be anything that is listed here. So it would be somecdn.com. Font source will be from the domain that it lists. Similarly, style and connect to only domains that is specified, and connect source applies to event sources, XHR requests, and also, if I am not mistaken, WebSockets as well. So let's see how this is going to help from an e-commerce standpoint, and how it can protect a storefront in an e-commerce platform as well. So that comes back to my question, right? How is CSP going to be good for an e-commerce platform, and from a platform's perspective that manages hundreds to thousands of storefront? How can we scale this solution for our merchants on our platform? How can we detect in advance of a sub-resource compromise and inform our merchants? How can we allow our merchants to decide what resources they should be loading in their storefronts? And how do we allow our merchants to profile the known good resources versus the known bad, or even worse, unknown domains as well? So there are a lot of problems, and we want to see if CSP can actually help us solve these problems. And it turns out there is the CSP simulation mode, and specifically the content security policy report only. So this response header instructs the browser to report any violations related to loading content, to report violations here in the report URI section. And that is an endpoint on your server. In this case, the browser is going to send a JSON formatted violation report to our endpoint. And note that with this configuration, CSP does not enforce any restriction for loading contents, but only reports the violations. And for merchants that heavily rely on third-party resources, it makes sense to evaluate the current state of your application before rolling out a draconian policy to your users. And as a stepping stone to complete deployment, you can ask the browser to monitor a policy, report violations, but not enforce restrictions. Now, the next step is crafting a policy for your storefront by evaluating the resources you're actually loading. Once you think you have a handle on how things are put together in your storefront, set up a policy based on those requirements. Crafting your policy is first analyzing your resource dependency. That gives you a great way to ensure your storefront functions flawlessly for your shoppers and mitigates the risk of web skimmer injections through compromised domains. And this is one of the major advantages of you'd get to know the known good resources for your storefront. Thus, we reach to the final phase of policy enforcement and alerting as well. So CSP's ability to block untrusted resources client-side is a huge win for our merchants, but it would be helpful to have some sort of notification sent back to the server so that you can identify and squash any bugs that allow malicious injections in the first place. So by combining the content security policy with the report URI, you can do exactly that. The CSP violation report now acts as a good resource for investigating mage card type attacks. This report contains a good chunk of information that will help you track down the specific cause of the violation, including the page on which the violation occurred, the page's referrer, the resource that violated the policy, and specific directives it violated. And it also provides a copy of the complete policy as well. So this allows e-commerce platforms to build intelligence of known good versus known bad domains, allows deployment at scale across our storefronts. Now, zero customizations are required. It's only at a configuration level. All pages on the browser can be monitored, including payments and payment pages as well. And now we have the ability to alert merchants about compromised domains across the e-commerce platform. Again, these are very well-known policies or headers that are used and supported across browsers today. Coming to the last mitigation is using of iframes. Iframes, now again, CSP directives as a binary approach, either the resource is allowed or denied. So what happens to content that you kind of trust but not completely trust? This is something that probably beautifies your page or something that way. Iframes can provide part of the solution, like by providing a separation between the application and the content that you load. So let's look at what protections iframe provides out of the box. So the content that is loaded is limited to the outline of just that iframe. When an external resource is loaded in an iframe, the browser's cross-origin policies kicks in. So no access to the parent DOM, no access to local storage, IndexedDB, or cookies. Sounds good, but I don't think it's good enough for the following reasons. Cross-domain iframes will still allow embedded resources to trigger alerts and pop-ups. It can even invoke browser plugins. It can autoplay videos, present submittable forms, thus giving a segue to phishing. And in some cases, when you iframe the same origin as the parent's iframe, it may get access to the window top location, window top object as well. So which makes it kind of scary. In comes the iframe sandboxing. Now, this further locks down the resource that you embed in your domain because it does not allow access to DOMs, to the parent DOM or IndexedDB. It does not allow access to the same origin, forget same origin, not even its own origin, access to render forms, access to render the pointer locks, access to execute any JavaScript, may it be event handlers, JavaScript URLs, or even no scripts, and also does not allow access to run plugins in any which way. Now that is, but how useful can it just be to lock down all of those, right? What happens if we want to give certain permissions and lock down the rest? So in such situations, there are granular flags that let us do that let us maintain a whitelist approach. So we can provide the ability for that sandbox resource to provide form permissions, to allow pop-ups, to allow pointer locks, that's mouse movements, to allow access to their own origin, to allow scripts to be executed within their execution environment, and allow access to top navigation as well. So by adopting a whitelist approach in which we only grant permissions to capabilities that are required, we've reduced the risk of embedding the resource in our storefront with no ill effects. So it's a win-win situation for everyone concerned. Can I use it is widely supported in all browsers today as well. This brings me to the end of my talk. I am, as mentioned before, available on the interwebs. And if I do not have the time to field questions, I'm definitely available on the Slack channel as well. Thank you.
Okay, I think I am good to go here. So this is Erkan Zhang. Let me bring up my presentation and we'll get started. Let me know if you have any trouble hearing me.
We can hear you and we can see your screen. You're good to go.
Awesome. Okay, let me try to put this in presentation mode. Can you still see it in presentation mode?
We can still see your screen, but it does not appear. We still see your slide decks on the left, 1 through 16. But
Oh.
yeah.
How about now?
That's great. Full screen. Good job.
Cool. All right, so quick intro. So my name is Erkan. I'm the founder of Jupiter One and the CISO of Lifomic. So I actually did a similar talk last year at BsidesSLC City in 2019 that talks about how we internally build our security operations on a graph database, a graph-based CMDB. This is an extension to that. And actually Jupiter One is the product that we built that supports that. But I'm going to talk about this in more general kind of concepts of the graph CMDB and using some of the examples of our own product to highlight that. And just so you know, I'll be sharing some code examples, and this is doable yourself with any graph database like Neo4j and other things as well. So a little bit of a recap from last year. So for folks who has not seen my talk last year, here's a link to it, and I'll go through a couple of the recaps so people have some kind of shared background and common background. So it's not kind of so abrupt when I jump into the use case. I'll go through this very quickly, and there's links here and at the end. You can kind of get more details about this GraphDB itself. Now, first of all, the reason that we built a graph-based CMDB or a operating model built on a graph is because of this. And because we want to analyze not just the resources and their configurations as a traditional CMDB or a configuration management database would do, but what we like to do is to be able to analyze the relationships and the context that are derived from these relationships. Because as this statement says, defenders think in lists and attackers think in graphs, and that's why attackers win. And we don't want them to win, right? We want to win instead. So a few things that we can do with the graph. And first of all, this is the data that we collect into a graph data model or a graph database. And it's not just the typical IT assets that people think about. And we actually have the graph objects represents anything that we can think of that's related to our security operations, to our compliance programs, and just overall our digital operations. We are very much cloud native and digital, so this is relatively straightforward for us to do. There's a lot of APIs that we can leverage to build this, and anything that's not API driven, we can still manually using a script to create these in the graph database. So like you see here, it covers anything on this list from policies to risks to organization users, accounts, even vendors, and vulnerability findings, and endpoint resources, network resources, agents on those hosts and servers, and of course, as well as our resources in the cloud, in the AWS infrastructure. So what can you do with this graph, right? So once you have this graph, there's so much that you can do that we find that we end up doing with this graph. Now this becomes our core and almost our operating system for our security analysis and the compliance program. So here are some use cases. I'm going to focus on one in my example in a little bit that has to do with access review. But these are some of the use cases that can be realized with this data in the graph. And the pattern, it really is pretty straightforward. And we have one single pattern, which is doing security as code and in an engineering pattern where we can use APIs to collect data and then use query to analyze and get insight from that data for any of these use cases. Now, let me describe a little bit more what this graph looks like. So a graph for this particular use case for GRC, policies, controls, and just overall program management may look like this. So you got an organization that has policies, which you have procedures and controls that implements policies. And then you have various compliance standards that you have to meet, and each standard has a requirement, and the procedures and the controls implement those requirements, and so on and so forth. Right, so this is a high-level view of what the graph data model looks like for this area of things. And then you can see the gray boxes where from here it connects to other subgraphs. And there's a graph for user management, account management, and vendor management. And here are some of the interrelationships of how the organization owns the account and which account has what service and has what user or user groups and so on and so forth. Now, this ties into the previous GRC data model, and it also ties into the vulnerability management data model, which is presented here. That everything in here surrounds with the vulnerability findings, which can impact a variety of different resources, like a host or application or code repo. And this graph, like here, for example, right, allows us to answer questions like, what's the pattern in these findings, right? So which weakness is probably the most predominant in our environment? In other words, right, so if we have 100 findings that's all exploiting a same weakness, so we know that is a weak point in our ecosystem. So that's what this graph represents. And then we have a graph that represents network and endpoint infrastructure of different hosts and resources and different entities in the AWS infrastructure and so on and so forth. Now, I'm going to use a specific example, and you'll see what questions can the graph answer. Here's some example questions specific to AWS. And I'm going to ask this particular somewhat complex questions and how we answer this with the graph query. And the question here is, are there internet-facing EC2 instances that are allowed access to non-public S3 buckets? Now, it's a long question. And in order to answer this question, it actually has 7 different criteria that it has to meet. And these are the 7 things that we have to check for in order to answer precisely, without noise, or without false positives, the answer to this question. So first, instances are active, they're alive. There are security groups in those instances allowing to or from the internet. And instances are publicly routable. And then there's network and VPC access, allowing the network access to the internet, and security group rules and IAM policies and IAM roles and so on and so forth. But you can read this in the slide. So all of these conditions has to meet in order for this particular question to be answered, right? So this is what this looks like with a graph query. So imagine that if you are to try to answer this across multiple environments at the same time, if you have maybe 50 or even 100 or more AWS accounts, and you have thousands of instances and hundreds and thousands of IAM policies and roles, and the equal amount of S3 buckets. So this becomes a classic security problem where you're trying to find the needle in the haystack. Now, with a graph, right, so assuming that we have this data collected and we have mapped out these relationships and how things are related to each other, so we can run a query like this, right? Basically traverse the graph and starting from the internet and looking for connections to security groups, and then looking for connections to AWS EC2 instances, and here's a cluster of them. And then looking at the IAM roles assigned to these instances, and then the policies assigned to these roles, and their access to the S3 buckets, and if they are labeled or classified as public or not. So this particular example, right, so showcases how you can use a graph query to do a graph traversal and do this type of threat and risk analysis, or configuration auditing, or whatever you call it. So this is a bit of a recap of why we built the Graph CMDB, and how we're using it internally to identify risks. Now, I'm going to move on to a particular use case that we've just recently did for our user access review. So the question is really this: how do we get cross-environment context out of the graph, right? So it's not just within the AWS environment itself, right? How do we connect the dots across multiple environments? So from one user accounts from one environment to another one. So let me describe these use cases for you a little bit. And a recent article from Microsoft that that you saw here below actually was from their RSA presentation just a month or so ago. And they've put out this report that says 99.9% of the compromised accounts did not use MFA, and only 11% of all of the enterprise accounts that they have visibility to actually have an MFA solution overall. So for us internally, the natural question is, are MFA enabled for all of our user accounts, right? Now with a graph, this can be answered pretty easily. Well, so first we thought that we have all the users, right? So we collected all the user informations from the different accounts. You know, we have accounts in Bitbucket and GitHub and Octet and so on and so forth, right? We have all of those aggregated into the graph, so we can easily run a query and something like this that says, you know, find user with MFA enabled not equals to true that has not been assigned or is not using or does not have an MFA device. So this query actually have two conditions. You know, one of them is saying that if the user itself doesn't have the MFA enabled flag as we've analyzed the configuration from a provider. And additionally, if that's the case, and also the user does not have a separate MFA device that we know of attached to the user account that's, you know, configured this way. So this checks for both of those conditions. Well, the result of that query when we first ran it says, you know, 569 user accounts with no MFA enabled. Well, that can't be right. We have actually, we're a small organization. We have less than 100 employees, and, you know, across multiple environments, you know, maybe we have 1,000 or so user accounts, right? Assuming that each person have 10 accounts, and that's roughly 1,000 accounts. So more than half of those had no MFA enabled, and that can't be right, because I know that that's not the case for us. So what was happening? Why were there so many false positives? It's actually because of single sign-on. So these users, they never log in directly to the provider. Instead, they log in via, we use Okta, right? So via single sign-on. So as you can see here, that these provider user accounts, right, as we call the provider APIs to get information about those users, and the provider is going to say, yep, they don't have MFA enabled. So if we ask GitHub and, you know, give me the list of users, or ask Jira or Google or Office 365 or KnowBe4, and these environments, they're all going to return and say, yep, here's the list of your users, and they don't have MFA enabled. Now, in reality, they actually do go through MFA because the logging flow is via Okta, single sign-on using SAML. So here's an example. In this example, I run a query just for my own user. And if you look at the query itself, I said, you know, give me the Bitbucket user with my name as user A. And that has an account, which is this Bitbucket account that connects an Okta application, which is this Atlassian Jira application. And that is assigned an Okta user, which is my Okta user right here. And show me if my Okta user has assigned or is using an MFA device. Well, it turns out I have 4 MFA devices configured. So what this query is showing you is that I am actually logging in through Okta and into Bitbucket, and I am, you know, using MFA for my Okta account, but Bitbucket doesn't know that, right? So, and the Bitbucket user doesn't have that property for MFA. So what we end up doing is, well, we know we have this information in the graph. You know, we just want to enrich this Bitbucket user entity to have that property, to know that I am a single sign-on user and I have MFA enabled if this graph condition is met. So here's what we did. But we also don't want to assume, right? So we don't want to assume that's always true. So we only want to do this type of connection, or we only want to update my Bitbucket user entity only if this condition is met. So we don't want to make the assumption that because we're using Okta, that all of our users are going through this flow. So what we have to do for accuracy and a level of assurance is to do some correlation using the graph. So for each user, we have to run that query, essentially, is to say, I have to correlate for each user that is not an Okta user. Then application is assigned in Okta, and the user have a matching user by email or whatever case that might be, that is assigned to this Okta application, the single sign-on application. And then my Okta user has the MFA device configured or assigned. So that's the condition. Now, how do we do this? We can do this with query and with code. So for the first condition, so this is the query we ran, right? You say, find a user with the unique identifier, the unique key, as the first user that has this account that connects to whatever account that might be, or it could be a Jira account, it could be a GitHub account, or KnowBe4 account, whatever case that might be. So these are generic representations of user and account. Now we say we want to find that account that specifically connects to a corresponding Okta application. And I want to find the users that are assigned to the Okta application. Then the user must be active. And then I'm going to compare this first user and the second user. And if their username or email or some other condition is met, then I can know with some level of assurance that this first user right here is actually a single sign-on user. So if that is met, then we set the single sign-on user, SSO user flag on user A to true. And then secondly, as you can see here, right, so we added a condition and say, for that same user, if that is a single sign-on user, I'm going to run a second query and to look for any of the MFA device that's assigned to that Okta user. If this is found, then we're going to set a MFA enabled flag to true on that original user. So what this should allow us to do is to filter out all the noise. And it turned out that actually worked. So after we ran that script, so this is the same example for my user. So my Bitbucket user now has a MFA enabled flag and a single sign-on user flag, both set to true. And that's what we use graph context, right? So this is just one example use case of how we use the graph context and use code and use query to enable and reduce the noise in our security operations and in our threat analysis, and in this case for access reviews. And when we run this query again, this is the exact same query that we run again. We identified instead of 569, so now we actually have 47 user accounts with no MFA. And we've went through the results of those 47, and that is actually correct. And remember previously we said we don't want to make any assumptions, right? So, and this actually caught a bunch of system accounts that these system accounts were not SSO users and they should not have MFA enabled flag set to true as intended, and they don't. And we also in the process actually identified a handful of user accounts that actually need remediation. So that's the end result, and I want to share with you some of the resources. So the code that we did for this particular exercise is available in our graph enrichment example repo. We also have, I've done a number of different SecOps automation examples that's in a different repo that you can check it out. And of course, check out some of my other talks at, this is the last year's talk at BSides. And then there's a talk that goes a little bit more deeper into the vulnerability management use case of using a graph database at RSA. This talk right here was actually joined by the CISO of Reddit. So this might be interesting for some of you. So I went through this very quickly. I want to leave you with this, right, is that the reason we built everything into the graph database is because we are consolidating our data into a knowledge base. And this knowledge base allows us to be able to query things and be able to take action with confidence faster using code and using query and using automation built from that. I think I went through everything very quickly, and I want to give it a few minutes to kind of go through any Q&A if there is any. How do we do Q&A here?
They can post it in Q&A and it'll pop up in the bottom of your controls as Q&A questions.
Okay. All right. I don't see any.
I don't see any in there right now.
All right then. Well, thank you very much. And that's the end of my presentation.
Thank you. We did see a hand pop up. If you have a question for him, Slack is a great median for a lot of us that hang and gather. I also see another question popped up, but feel free to send that to him in Slack while we get set up for Renee to start here. And Renee, we are seeing your screen. It is coming in good. You're still muted though. I don't know. You can wait 5 more minutes, or if you want to check your mic.
Perfect. Can you hear me now?
You are coming through just fine. So if you want to start early, but this is published, so maybe you want to wait till on time in case somebody is expecting to join you right at 3. So it's your call. We're good either way.
Yeah, let's wait for a few minutes.
If you're good at beatboxing or anything like that, feel free to throw some of that.
I can say that I'm on the 4th day of the shelter-in-place ordinance here in California, and I already feel a little bit like this. So yeah, I was looking forward to meeting everyone in person, but I appreciate the online opportunity as well. I think we all feel a little bit disconnected, so this is a great opportunity to stay connected and learn something, hopefully.
Yeah, big thank you to you as a speaker and all the rest of our speakers who are willing to pivot last second. I mean, just like the whole con, everything. Definitely different times than anything I've had in my life.
I'll start right at 3. Okay, let's get started. You still hear me?
Yep, you're good to go.
Excellent, excellent. Well, my name is Rene Kolga, and I have always dreamed of speaking at BsidesSLC, so this is a dream come true. I really appreciate the organizers and the sponsors for putting this together. Topic of the day, I think it's a pretty hot topic, ransomware. Even though, believe it or not, ransomware started back in the 80s, but 3-4 decades later, we still, for some reason, seem to be unable to tackle that problem. And that's exactly what my presentation today is about. Quickly about myself, Rene Kolga, I've been in security for quite some time, worked for companies like Altiris, Symantec, Citrix, and a number of startups, mostly in the areas of anti-malware, encryption, and insider threat. So today's talk is about ransomware and why we can't seem to be able to tackle this problem. I will very briefly talk about how ransomware works. Then I'll spend some time going over 4 typical methods that the cybersecurity industry and endpoint security products attempt to detect and stop ransomware with all of their pros and cons. Then I'll talk about how things can get even worse and talk about one of the evasion techniques that ransomware can potentially leverage to be even more deadly. And finally, I'll show a couple of live examples of ransomware that's bypassing 2 major endpoint security products. So let's get going. I've already showed this and shared my desire for connection in these strange times. So again, appreciate that the organizers decided to continue with the event even in this online form. Okay, so let's get down to business. What's the typical ransomware workflow? I'm not going to talk about how ransomware gets in, whether it's phishing, insecure RDP, or something like that, right? That's irrelevant. We all know that the bad guys will find a way. But what happens then? Obviously, ransomware tries to find your valuable files, your office data, maybe a database, maybe pictures. It tries to, it will keep the system files in place because it wants the OS to be still bootable, so it can display the message and ask you for some Bitcoins. So it reads those files that it wants to encrypt. It encrypts the content in memory. And then it has a choice of what to do, how to get rid of the original unencrypted files. And it can choose to do one of the following things. And there are other ways as well. I'm just listing 3 here. One option is to save the new encrypted file on disk and then use a delete file operation to get rid of the original file. Another option, pretty devious one, is to write the encrypted data straight back into the same file, into the original file, and maybe even keep the same file name. And that may make the restoration even more difficult. And then another option is to create a new file on the disk and then replace the original file using a rename operation. So these are just a few ways ransomware can get rid of the original data. And that's pretty important to understand if you want to stop ransomware, right? So now let's look at the various detection methods that the industry has been putting forth to try to detect and stop ransomware. And as we all see from the news, obviously those attempts so far have not been very successful, unfortunately. I'll describe and explain exactly why. So let's start with one of the more basic methods, the static file analysis. This is a generic approach that antivirus and anti-malware and anti-ransomware products leverage to stop any virus, including ransomware. So it's not specifically designed to ransomware per se. So this is where an antivirus or similar product looks for some signature, right? It can be sequence of terms, words, and things like that. What are the pros? Well, false positive rate, FP rate is pretty low. It's very rare when an antivirus product says that this binary is malicious while it actually isn't. So that's obviously a plus, because we're already, as security professionals, we are overwhelmed with those alerts and false positives. What else? Another good, the last bullet point here is pretty important, actually. It stops attack before any files are encrypted. So it does not sacrifice any files before it triggers the defenses. So that's great. What are the cons? Well, obviously, we all know signature-based tools are pretty easy to bypass, even if they leverage machine learning or AI-based signature. So it's pretty easy to bypass. So hence, false negative rate is pretty high. And how the bad guys, how do the bad guys bypass those defenses? Well, they use cryptors, packers, and various ways of obfuscating and changing those signatures for every attack they launch. Okay, so let's move on to another technique. Another pretty basic, even surprising technique, I would say, is a common file extension blacklist-based approach, where a security product will look for well-known ransomware extensions and say, oh, look, if a file is being created with this file extension, dot something, then it must be ransomware, so we are going to stop it. And what are the pros? Well, pretty low FP rate. Again, no damage is done, or maybe one file is sacrificed to ransomware, but then defenses kick in and the ransomware is stopped. Well, obviously, I don't need to explain probably that it is very trivial for attackers, for ransomware writers to bypass, unfortunately. The only thing they need to do is to use a random file extension, or change a file extension, or not rename files at all, right? Keep the same file name with the same extension after they encrypt the data. And if you don't believe that these tools are actually, this technique is actually being used in some of the leading security products, I've obfuscated them, the logo of the product here, but you can see this one of the radio buttons, file encryption, a process that created a file with a known ransomware extension was terminated. And then there is even a separate setting specifically for locky ransomware. So believe it or not, that method is actually being used. Next, deception, right? This is where a security product would create a set of files, kind of bait files. And if any of those files are touched, then we can commit the process that touched those files as ransomware. So it has a benefit that it can detect ransomware that other methods may not be able to detect or stop, like the static file analysis, the first method we looked at. What are the cons? Well, obviously there is a very high chance for FPs here, false positives, because typically, because one, the user can touch those files, or a program can touch those files and hence trigger those defensive mechanisms. And then, of course, the bad guys know about all these methods. So as these bait files or honeypot files tend to be created as hidden files or folders, ransomware can just bypass and skip those hidden files and folders, and hence not trigger this particular method. Okay, moving on to a little bit more advanced techniques. One being the mass file operation. What is ransomware? What is ransomware typically known to be doing, right? It will do a lot of reads and writes and probably delete or rename operations. Well, what if we define some kind of a threshold, a limit? Like if we see so many of these file operations within a certain period of time, then it seems like this is ransomware. So again, it's a little bit more sophisticated. So hence it can detect some of the ransomware that other methods may not be able to detect. But obviously, there is a concern about false positives here as well, because you as a user may be legitimately just moving one folder to another, right? And that would potentially trigger this threshold. And then some files will likely get encrypted, will get sacrificed before this threshold is met. And finally, the attackers, how attackers bypass these methods, they either slow down the encryption process or potentially spawn multiple processes for different files that they're encrypting. I believe the infamous LocalGoga ransomware actually was launching a separate thread for each file they wanted to encrypt. And hence the encryption itself was actually super slow, but maybe that's why LocalGoga was able to bypass even so-called next generation antivirus products and cause significant damage. And finally, kind of variation on the previous method is the method that measures the change within the data itself, within the files. It's not just looking at the mass file operations, but actually looking at the content of the data and measure the randomness, for example, of the data using an entropy calculation, for example. Again, there are pluses, like with all methods, and it will have fewer FPs than the previously described method, because this is more sophisticated. It's not just looking at the mass file operation, like moving a folder from one drive to another. However, even in this method, some files will likely get sacrificed, and then attackers can only encrypt maybe parts of the file, so random sections of files, or encrypt in chunks, and thus potentially bypass these detection methods. Okay, so this is kind of my very non-scientific rating of the effectiveness of the 5 methods I just described, from 1 to 5. As you can see, none of them are at level 5 or even 4. So that's one. That's why we still see ransomware headlines in the news almost every week, and that's why most endpoint security products actually combine multiple, if not all, of these techniques in their products in the attempt to increase the overall efficacy. But as we all know, unfortunately, the efficacy is still far from where it needs to be. Okay, so let's switch gears a little bit. No ransomware presentation is complete without mentioning WannaCry, right? This is probably the most well-known ransomware that affected over 150 countries, billions and billions of economic loss, surgeries had to be canceled, etc., etc. Right? And that's, everyone remembers about that. But what some people actually don't remember, I think, is that WannaCry was actually completely stoppable, completely preventable, right? Because Microsoft actually released a patch for an underlying vulnerability almost full 2 months prior to the WannaCry attack happening. So the only thing you had to do to be fully protected from WannaCry was to leisurely, within 2 months, apply a Microsoft security patch. You didn't need a firewall, you didn't need an antivirus, you didn't need any other fancy products to be fully protected from WannaCry. And still, the damage was substantial, as just described on the previous slide. So, so what if there was a method that we actually don't have good defenses against? And and there are many, I'm sure. This is just one interesting evasion technique that our research team discovered last year. And I'm gonna give you a little bit of details about this technique called replace. It stands for rest in peace and replace at the same time. So this is an interesting technique. Why is it interesting is because it's not just an evasion technique that allows you to bypass your antivirus or anti-ransomware products, but it also is a blinding technique in the sense that it leaves no traces in tools like EDR, endpoint detection and response, that are meant to provide that kind of a recording of all the events that happen on your laptops, desktops, and servers, so that if attack happened and the damage was done, you can, so to speak, rewind the tape and investigate this incident and see how did the bad guys get in, when, what did they take, and hence kind of you'll be able to, the idea is you'll be able to fortify your defenses so those similar attack in the future would not be successful. So the replace evasion technique actually not only bypasses the defenses, but also leaves no trace in those tools. And that's what makes it quite interesting. So what is replace exactly? If you remember one of the first slides, I showed you how ransomware works, and specifically how it gets rid of the original unencrypted file. Well, replace is a variation of the third method, the rename operation. And what exactly happens here? It actually leverages a pretty obscure function called define DOS device. What is define DOS device? It's basically allows you to, instead of pointing to a file directly, use the symlink or symbolic link to point to it, right? It's kind of a shortcut, right? So instead of pointing, and you can create a symlink for a drive, for a folder, or my secret cheesecake recipe, right? So what happens here is that if you pass a symlink to a function that a security products typically hook in order to evaluate whether this file system operation is legitimate or not, whether it's done by the virus or ransomware. If you pass, instead of a full path, you pass a symlink using define DOS device, the operation, the driver actually receives an error code while the operation succeeds. So what happens here is that as the security products filter driver receives this error code 33, it assumes that the operation failed, and hence it skips all the detection, malicious activity detection logic completely, while the operation actually succeeds. So I know I'm going a little bit technical here, and you can read much more details in our report about exactly how it works. And we have sample code, POC code posted on our GitHub repo as well. But I think most interesting thing is to actually see a demo of this, of how this technique can bypass some of the leading security products. So I hope you can still see my screen. I have a VM running here. And what I have on this VM, I have some data in the documents folder. So let's imagine there's some sensitive data here. And I also have a proc1 running to see the results of the operation. And in this demo, I'm using Windows 10 built-in anti-ransomware feature called a CFA, or Controlled Folder Access. It's, as you can see, it's enabled. It's the folder I'm showing the data in is part of the default configuration as part of the protected folders. So this CFA technique is meant to specifically protect your data and resist a ransomware. So let's now run a simulated ransomware and see what happens. Okay, I'm running a simulated ransomware here. And if you look at the procmon results, see the process ransomware.exe, it attempted to replace or encrypt these 4 files that we just looked at, and it got access denied. So CFA worked as expected, right? It prevented ransomware from tampering with this data. So we can double check that the data is indeed intact. So now let's use the same ransomware, but that leverages now this evasion technique, this replace evasion technique that I just described. So now let's run replace. And something interesting has happened. One, we see that replace, all 4 operations received a result success. We don't see any folder or path or file name, anything, right? So it did something to nothing. But now let's look at the data itself. And as you'll see that actually the files were encrypted. The files are gone now. And CFA did nothing, right? So that was interesting. So let me roll back to another snapshot of this demo and show you an example of a different endpoint security product. This time it's not going to be Microsoft CFA. It's going to be a leading endpoint security product by Symantec Endpoint Protection, or SEP. So here is setup is similar. We have our procmon. We have sensitive data. This time it's not files or images. This time it's a host file, right? That's a pretty important file to protect. And we can see the file is just fine right now. And SEP, Semantic Endpoint Protection, actually has lots of different modules. It has the exploit mitigation and an unknown threat detection and a variety of other techniques. Everything is enabled, everything default configuration. And one of the interesting capabilities that SEP has, it specifically has a protection against tampering with a host file, a DNS a change in a host file detection. And as you can see, those set to prompt if anyone attempts to tamper with these particular files. And as you can see, of course, the SEP is complaining here is actually, I didn't update the definitions are old, but believe me, if I had, then the result would be exactly the same. So that's that does not really matter. So let's now run a simulated malware that or ransomware that attempts to encrypt that host file that SEP protects. And let's see what happens. Looks like SEP works exactly as designed, right? It says someone is trying to tamper or modify a host file, and do we want to block or allow this? Well, obviously we want to block this. So if we look at the procmon, you can see malware attempted to tamper with this particular file, and it received access denied. So let's double check that the file is fine. Okay. And so now I'm sure you already know where I'm going with this. Now I'll attempt to do the same exact operation, but now leveraging this evasion technique called replace. And let's see what happens. Well, as expected, you can see replace.exe received success in doing nothing. There's no file path, nothing. So you won't be able to really investigate this if this happened. And now let's look at the host file itself. What happened there? Well, not surprisingly, host file is now encrypted. So that's kind of a quick demo. And again, replace is just one of dozens, if not hundreds of different techniques that the bad guys can leverage to bypass your defenses if those defenses leverage a blacklisting approach. There's just no way to stay ahead of the attackers 100% of the time if all you do is attempt to investigate and stop their new methods. So this discovery received quite a bit of coverage in the likes of Bleeping Computer, but what can be useful for the audience potentially is that there is this very simple tool that we posted on our website that you can test your endpoint security product against this for susceptibility to this replace technique. It just attempts to encrypt one file on your desktop that you pointed to. It just leverages XOR encryption. So obviously you can just rerun it and get that file decrypted again if your security tool was not able to stop it. So some of you may ask that, well, why, if this technique could be so potentially dangerous and damaging, why release details about it, right? Well, obviously we followed the responsible disclosure process, and typically responsible disclosure is 3 months, right? We actually gave the industry about 9 months. We reached out to Microsoft, we reached out to dozens of security vendors with the details about this evasion technique. We got some response, and there were a handful of vendors that actually addressed this issue in their antivirus and endpoint security products, because it's actually fairly easy for security vendors to detect and properly handle rather this evasion technique. But unfortunately, from most of the vendors, we heard exactly nothing. So at some point, you need to release this to the public and hope to put pressure on the rest of the industry to address this issue to keep our environments secure. That's all I had to share with you. So happy to connect. Happy to connect with anyone. LinkedIn is probably the best way to connect with me. Yeah, hopefully you enjoy this. Thank you very much.
All right, good afternoon, everyone. My name is David French, and thanks for attending my talk today. And this is A Chain is No Stronger Than Its Weakest Link. So today I'm going to be talking about the ways in which adversaries abuse Windows shortcut files and how defenders can hunt for and detect this behavior both statically and dynamically. And I'll also be talking about a model that Bobby Filer and I worked on to classify shortcut files as malicious or benign. So just briefly, a bit about me before we get started. So I'm a security research engineer on Elastic Security's protections team. I work on analyzing adversary tradecraft and developing detections and hunts. And I enjoy increasing the cost of an attack for adversaries and finding ways to help defenders get the upper hand. I'm a contributor to Problem Child, which is a graph-based framework used to discover anomalous patterns based on process relationships. And I used to lead hunt strategy at a large financial institution. And I'm a co-author of the Elastic Guide to Threat Hunting, which is a free book just to help practitioners get started with threat hunting. So let's just take a minute to go over the agenda for this talk. So I'll be talking about some of the reasons why I think attackers are abusing link files, and have done so for several years now. For those who are not familiar with analyzing link files, I can go over the file structure and the properties that practitioners need to know about when they're either analyzing or detecting malicious links. And then I'll walk through some examples of how attackers are abusing link files in the wild to help them achieve their objectives. And then I'll call out the interesting features of those files along the way that make them stand out as suspicious. And then I'll talk about how we built a model to classify link files using machine learning. And I'm going to be walking through this process to show how security practitioners can apply their domain knowledge to extract features from samples and then apply data science techniques to try and solve a security problem. And then we'll wrap up by talking about some possible next steps for the research and then share some useful resources for people who want to learn more. So before we cover link file anatomy and how attackers are abusing them, let's go ahead and talk about some of the reasons why I think they've been abusing this file type for some time. So here are some of the reasons why I think they've been abusing them for several years now against their targets. So firstly, crafting malicious links or modifying existing ones to include a backdoor is super easy. The barriers to entry are really low due to the availability of just off-the-shelf open source offensive security tools. And if you're interested in those, I've included a few examples on this slide. So although some people get frustrated over free and open source security tools or offensive security tools, I think they really provide blue teams with the opportunity to simulate adversary activity pretty easily, test their defenses, and then understand their organization's ability to detect or prevent that activity. So I think traditional AV software has typically had poor detection rates for malicious links from what I've observed. Many of the scanners on VirusTotal miss malicious link on day one, but then detection rates seem to move towards 20% or greater within a few days of the file being submitted. So I think a couple of reasons these low detection rates might be a thing is due to the fact that there are just so many different combinations of values that can exist in link files. I think AV companies might be concerned about making mistakes or quarantining or deleting the wrong files and then disrupting a user's workflow. And then we've got an easy delivery. It's really easy to get weaponized link files into a victim's environment. So most email gateways, proxies, firewalls, they're not configured to inspect or block this file type because of its legit use cases. And then finally, I think lack of user or practitioner awareness might be a contributing factor to why attackers often evade our detection when using this technique. So users are probably not aware of the dangers of shortcut files, and security analysts might not be familiar with the ways they can be abused and how they can analyze, detect, or hunt for them. So just to sum up this slide, really, I think once we can reliably detect and prevent a technique, it's only then that attackers will be forced to go through the expensive, time-consuming process of changing their behavior. And this will increase the cost of an attack for them and then tip the scales to give defenders the advantage. So as you can see from some of the examples I've included on this slide, attackers have been abusing link files for over 10 years. The use of this technique is still prevalent and successful for them. So if you look in the MITRE ATT&CK knowledge base of adversary behavior, there are about 30 references there, and all of them link to a report with details of a successful intrusion against an organization that used this. So I won't read off all these examples for you, but you can see that attackers have used link files to do things like maintain persistence in the victim's environment, steal credentials, obtain initial access, and execute ransomware. So for those of you who are not familiar, let's move on to talk about the structure of a link file. So this is going to show you the minimum amount of information that you as practitioners need to know in order to be successful in either detecting or abusing link files, depending on what your goal and your day job is. So when I think about the minimum amount of information that defenders and attackers need to know, I think that blue teams must know the basic anatomy of link files and how to analyze them in order to identify one as malicious or benign. And then attackers must know how link files can be abused and what defenders are looking for in order to evade detection. So in a nutshell, a link file is just a convenient pointer to another file. The target of the link file, like you can see at the bottom right hand of this slide, it's not the only interesting information. So there's a bit more to link files than what you can see when you just right click one and select properties. So in these next few slides, I'll go through the structure and properties of a link file that you need to know about. So Microsoft's specification for this file type is about 50 pages. I'll save you some time and just call out the highlights. So here are the values of the file signature or the magic number and the class identifier that enable us and the Windows OS to identify link files even if the file extension is not .link. So you've got several open source link file parsers available. I like to use Eric Zimmerman's LE command. It's fast, it's reliable, and there's an option to parse link files in bulk. So I'm going to be using LE command in the examples that I'll be walking through in this presentation. So here's an example output from LE command after a benign Internet Explorer shortcut is passed, just an example. I'll call out the properties that you need to be aware of. So first and foremost, the target of the link file is stored in a list format in the file structure. LE command just goes ahead and passes that out for us and conveniently displays the full path for us. And then you've got the file size property. This is the file size of the link file's target, not the link file itself. So something to be aware of if you're doing forensics. Also, just above the file size, you can see the modified, accessed, and created timestamps. These are super useful during digital forensics investigations, like when you're producing a timeline of an intrusion or maybe an insider threats activity. But these are going to be out of scope for this talk. So we're talking about how link files are abused and then how to tell when that's happening. And then you've got the 32 link flags. These specify which structures are present in the rest of the link file. So some of them are reserved or unused. As a couple of examples, the has arguments flag means that the link is saved with command line arguments, and has icon location means that a path is specified to display an icon for the link file. And then you've got the drive type property. So this specifies the type of drive that the link file is stored on. So for example, it could be stored on a fixed drive, removable media, or a network drive. This value is another one that's useful in forensic investigations to verify what files were accessed by a user or an attacker. And then here's some information that's useful if you're interested in tracking adversaries and relationships between leak files and intrusion campaigns. So when an attacker creates a malicious link file in their environment in preparation of delivering it to their victim, the volume serial number, net BIOS name, and MAC address of their computer is included in the link file. So some attackers are either unaware that this happens or they forget to wipe one or more of these values. So this data can be used for tracking campaigns or adversaries on services like VirusTotal. Another one to watch out for is the user SID. So that's not shown in this example, but that can give you information about the network, computer, and user account that was used to create the link file in the attacker's environment. And then we've got the show command. So this specifies the state of the target application's window after the link file was executed. So keep an eye out for the show min no active value. This means that the application window is going to be hidden from the user or the victim when they click the link file, and this could be an indication of the attacker trying to hide their code execution from the victim. And then finally, here are a couple of additional properties to be aware of that weren't shown in the example that we just walked through. So the icon location value specifies the path where the link file's icon is stored. And the command line arguments, they're executed with the link file's target when the link is clicked. So in this example, we can see the link file's target is PowerShell, and then we can see a script in the command line arguments being executed. So the script imports the bits transfer module and then reaches out to a URI to download a file called 7z.ping. So this one looks really suspicious at first glance. So in this next section, we'll review some of the ways that attackers use malicious link files to achieve their objectives. I'll walk through an analysis of some malicious examples and then point out the features that make them stand out as suspicious along the way. So what I'm going to give you here is some information that you can use in your detection or threat hunting efforts. So weaponized link files are commonly used to obtain initial access or to maintain persistence in a victim's environment. To gain initial access to a target environment, attackers will often craft a link file to execute a malicious one-liner or a script. And that will usually leverage living off the land binary like PowerShell or the command prompt. A common example would be a PowerShell one-liner to download some malware. And then link files during this phase are usually delivered via email or in a compressed archive file to the victim. They could be embedded in an Office document, or they'll include a URL for the victim to download and execute the file. And then for persistence, attackers will often place a link file in a location where their one-liner or malware will execute every time the user logs on or when the computer starts up. Or they'll modify an existing shortcut file to include a backdoor. So each time the shortcut is executed, the original application will load, and then the malicious code will execute in the background as well. And then another persistence technique is to craft a link file that forces user authentication. So this can allow the attacker to harvest the user's password hashes, and then they can try and crack those to obtain the clear text password, or they can use those in a pass the hash attack. So let's analyze some malicious links and then identify what features can help us identify them as suspicious. And then we can use those features for detection, hunting, or to build our own classifier that we'll talk about in a bit. So here's an example of a malicious link that was used in an intrusion campaign to gain access to several organizations. FireEye attributed this particular example to APT29, and the attackers sent a phishing email to their targets that included a URL to download a zip file from a OneDrive account. And then that zip archive file contained a malicious link. And then when that malicious link was executed, a PowerShell script was executed, which extracted a decoy document for the user to view to distract them. And then in the background, a Cobalt Strike beacon DLL was extracted, and then that was executed. And that DLL provided a connection back to the attacker. So when a link file is executed, the new process is spawned as a child process of explorer.exe. That can make dynamic detection a bit of a challenge, but there are other ways to identify malicious link files, and we can walk through those examples. So let's examine this link file that was used in this campaign and understand what makes it look suspicious. So when we pass this malicious link file and start to look at its properties, some things immediately stand out as suspicious. So this link file's target is PowerShell.exe, which is a commonly abused binary used to execute malicious code or scripts. And then it's got long command line arguments that usually indicates the presence of an encoded command or a script. And we can see in this example, it looks to be a base 64 blob of encoded data. And then we've got the parameters non-interactive to prevent an interactive prompt from being displayed to the victim. And then execution policy bypass to bypass any default PowerShell kind of execution policy that's configured. So something that's important to note with regards to the command line arguments, when you look at the properties of a link file in the Windows UI, the file's target and command line arguments will be truncated after 260 characters. So in an attempt to evade detection, attackers have been known to craft malicious links with a benign target and then include some padding like white space before the command line. And then that will hide the full value from the Windows UI and sometimes evade detection or kind of a human analyzing the link file. And then here are some additional features that help us identify this link file as suspicious. So I mentioned earlier that the show command, if that's set to show min no active, that will mean that the application window of the new process will be minimized and not immediately visible to the victim who clicks. And then this is a good one. So link files are usually between 4 kilobytes and 20 kilobytes. This one is 400 kilobytes. Whenever I see a large link file like this one, it leads me to believe that the file contains other embedded content like files or scripts. This one is, if you recall from earlier, it contains a malicious DLL and a decoy PDF document, which accounts for the larger file size. And then the zone identifier is a good one to look out for as well. So depending on the internet browser or the application that was used to download the file, a zone ID alternate data stream will be added to the file to indicate it was downloaded from outside the host network. So a zone ID on a file greater than 1 typically means that it came from outside of the network. Another interesting feature is the entropy or randomness of these link files. So the top screenshot shows the entropy of the malicious link that we've been talking about. And the bottom one shows the entropy of just a benign Google Chrome shortcut file. So a link with high entropy can be an indicator that the file contains compressed or encrypted content. So for this example, the number of suspicious features have really added up. So let's move on to look at another couple of examples. So another technique that attackers can use is to modify an existing link file to include a backdoor. So each time the user clicks on the link file, say it was Google Chrome, just as to see this example on this slide, Google Chrome will still execute. So the original binary is executed, but the backdoor is also executed in the background away from the user. So PowerShell Empire has got a pretty good module that enables attackers to carry out this technique easily. Invoke backdoor link just lets you specify a link file to include a PowerShell stager. So I remember working at a company where a red teamer did this, and it was a bit tricky to figure out exactly how the PowerShell stager was being executed. So PowerShell was shown as the child of Explorer.exe. It's not something that blue teams are typically monitoring for, because that behavior looks pretty normal and happens all the time. But the red team had backdoored Windows Server Manager on several servers. So whenever a system administrator logged on, the stager executed and then a new C2 channel would be established. So another technique available to attackers is to include an IP address or URI in the icon path of a link file. So when Windows renders the link file in Explorer, it forces SMB authentication from the victim host to the attacker's IP address. So one way to reduce the effectiveness of this one is to block egress SMB traffic from your network, and that will stop them from capturing the hashes and trying to crack them or using them in a pass the hash attack. But still, if the attacker's already in the network and they place a link file on a heavily used network share, it can still be quite effective at capturing hashes from thousands of users inside your network. And here's an example of that technique being used for your reference. So offensive tools like LinkUp make it easy to craft one of these link files to carry out the technique. And then you can use the SMB authentication capture Metasploit module, and then you can collect the password hashes. So given this presentation is only 30 minutes, I don't have enough time to go into detail about the behavior-based detections for malicious links. Elastic is open sourced event query language, which is originally created for security detection and threat hunting use cases, and it's currently being integrated with the Elastic Stack. It's easy to learn and read and write queries. You can query on sequences of events for different event types. And in the appendix of these slides for your reference, I've included some behavior-based detections for malicious links. And you can check out the Equal Analytics library if you're interested in free detections. There are about 130 free analytics for detection, and they're all mapped to the MITRE ATT&CK matrix. So with regards to hunting for malicious link files in your environment, here's a crude but effective method that can produce a big win for your team. So it's amazing how many threat groups try and evade our defenses, but then they risk giving themselves away by creating a link file in the user's startup folder to maintain persistence. And then that link file will execute every time the victim logs on. So it's one of the oldest tricks in the book, but it still goes undetected in a lot of environments because defenders aren't looking. So a quick hunt would be to use LE command to parse the link files in commonly abused locations on your endpoints. And then you could index that data in a central repository or SIM. And then you can query and visualize that data to surface anomalies. So a simple but effective method is you can sort the results in ascending order by the link file's target or command line arguments. And then once you've learned what's normal in your environment, this should be a low effort hunt to either automate or just complete periodically. So one way to approach the problem of identifying link files as malicious or benign is to call it a classification problem. So while examining several link files and then identifying the features that make them stand out as suspicious, we tried to build our own classifier to classify them using data science techniques. So the next few slides show a practitioner's attempt to use machine learning to classify link files and explain the process from start to finish. So my goal is that this shows practitioners how accessible data science techniques are, and that machine learning can be effective at solving a problem most of the time, but it's not a silver bullet. So early on in the talk, when we were parsing link files and then identifying the important features to help us understand if they're malicious or benign, we were doing feature extraction. We're essentially transforming our domain knowledge into features, and then we can apply machine learning or other data science techniques to try and solve the problem. So I analyzed lots of malicious and benign link files and started building out a data set. So when we decided to build a model, I had to normalize that data before I could run it through any algorithms and then try and predict whether a file is malicious or benign. So how do we go from thousands of link file reports like the one shown on this slide to something like this, which is an array that represents the features of the parsed link file shown on the left-hand side. So the model that we want to run our data through needs to see data in this kind of numeric format. So some features of a link file, like file size or entropy, they're already in a numeric format, so those are easy to handle. But how do you represent features like command line arguments as a number? So this was called feature engineering. So we were asking questions of the link file data. So we separated file sizes into bins. Larger link files would be in a bin with a higher number. And for values like the show command, we can just use the pandas library's factorize function. That gives a numerical representation of these values. And then for the remaining examples on this slide, we just create features in a binary like true or false, 1 or 0 method by checking each link file for certain values. So does a link file have long command line arguments, true or false? Does it have high entropy? That kind of thing. So the end result was just this normalized data set of malicious and benign kind of labeled link files. So then after preparing the data set, I started looking at possible methods to classify link files. So one option was a decision tree. Very simple example shown on this slide. So decision trees answer sequential questions and then operate in a if this, then that method, and then they lead us to the answer. So is the file malicious or benign? Advantages of decision trees are that they're fast, they don't need a lot of data, they're easy to interpret. Disadvantages that they're slow to train and then difficult to tune. So then we decided to try and use a random forest classifier. So this classifier essentially takes a set of decision trees from a randomly selected subset of the data. And then what you end up with is multiple trees with different portions of data. Each tree gets a vote on what the answer should be. And then those votes from the individual trees are aggregated to decide if the final class of the link file is malicious or benign. So the good thing about this type of classifier is even if a few individual decision trees are prone to noise, the overall result, once all the votes of the decision trees are aggregated or considered, should be correct. So here's some information about the experiment that we set up using the data set and training a random forest classifier to try and identify the links as malicious or benign. So the data set consisted of around 2,500 benign and 30,000 passed and labeled malicious link files. So this is quite an imbalance, but this is a common challenge when attempting to solve security problems using data science. But the extracted features should be descriptive enough to separate malicious from benign samples. So let's move on to talk about how we trained the classifier and then what the results look like. So the next few slides show what we did with the data set of link files and the random forest classifier. So at this point, every link file in the data set was passed and normalized into an array, what you see on this slide. So the data was set into two data sets. It was kind of an 80%, 20% split. So we had the training data set to train the classifier, and then the 20% left in the test data set for the classifier to try and classify those link files as malicious, benign, and then we can kind of analyze those results. So we use the training data set to train the classifier on what a malicious versus benign link file looks like. And then the link files in the test data set were reserved. So once the classifier was trained, we had it classify the link files in the test data set. And then the output from that was an array of labels for the link files to tell us if the classifier thought they were malicious or benign. And then for the results, we decided to use a confusion matrix to analyze the model's accuracy. So this matrix shows the count of true negatives, false positives, false negatives, true positives. So in general, we want to keep the false positives and false negatives quite low. And then to put these results in simple terms, 32 files were classified incorrectly out of almost 7,000. And then the vast majority of files were classified correctly. So I would say before this model is production ready though, I'd like to increase the number of benign samples in the data set to observe how this accuracy changes. And I'd like to obviously also ensure that there isn't a huge increase in false positives. So we'll just spend a minute talking about what the classifier didn't do well on. Like I said, machine learning can work a lot of the time, but it's not 100% accurate. False positives consisted of link files that utilize commonly abused binaries like cmd.exe to execute one-liners. So we had software, link files from software like pzip archiver, PDF creator, and some PC optimizer software. And then some of the link files that kind of slipped by the classifier completely were pretty interesting. So a couple of backdoor link files, internet browser shortcuts that would communicate with the attacker when they're executed. And then a couple of LOL bins using to execute things like malicious DLLs. So when I think about what we could do better, we could look at using something like TF-IDF that can determine the importance of each word in the command line arguments. And as I mentioned earlier, we could continue building a data set to kind of balance the number of malicious and benign files out. So just to wrap up really quick, as I said earlier, I think attackers will continue abusing link files while the detection rates are still quite low. Once defenders can reliably detect and disrupt the effectiveness of this attack is when the attackers will be forced to abandon this technique in favor of something else. So hopefully I've shown you that there are several opportunities to detect or hunt for malicious links. And when we consider applying machine learning to try and solve classification problems. The domain knowledge of practitioners is really valuable for doing things like feature extraction. And data science techniques are accessible to practitioners, but if you're able to work with an experienced data scientist on a problem, they can help you avoid common pitfalls like interpreting results incorrectly or maybe choosing the wrong algorithm or classifier to use. And then it's just important to note that this research doesn't solve the problem entirely. I'd like to continue building the data set of link files and extracting additional features for the classifier. And now I'm looking to see if we can build a machine learning job in Elastic Security to detect malicious link files. So I think I'm at the 30-minute mark. You can reach out to me on Twitter, or I'm on the BSides Slack workspace, so you can reach out to me there. But yeah, thanks for attending.
Thanks, David. That was awesome. Up next, we got Jason Bertman. He's going to be talking to us a little bit about Wi-Fi Pineapple active detection via Raspberry Pi Zero. So whenever you're ready, Jason, feel free to jump on and get started.
Awesome, thank you. It says I cannot start my video because the host has not stopped it. Now I'm just going to try sharing and see what happens. A good start. How's that? Can you see the presentation all right?
Yep, it popped up and you're loud and clear.
Awesome, thank you. All right, so my name is Jason Bertman. I work at Stage 2. Today I'm going to be talking to you guys about detecting pineapples via Raspberry Pi, via a small piece of hardware that we built that kind of functions as a physical security token. It's more so just a research project. So kind of detail, if you haven't had experience with pineapples, exactly what pineapples are, how they function, what things they take advantage of, and how we can sort of counteract that. Most of my days I'm taking advantage of those things on the red team side, but this is more of a blue team sort of research. So hopefully you guys get something out of this. This will be a pretty quick presentation, probably 20 to 25 minutes. So definitely feel free to leave any questions you want in the Q&A section or in the chat. But I'm glad that we could at least put together this virtual presentation for everyone. So just to kind of begin very quickly, I'm going to kind of go over exactly what a pineapple is and how it works. Some of the hardware alternatives for pineapples. Not everyone has access to a pineapple. Some people find that the $40 to $120 price range is a little too steep for them. So I'll kind of go over how I approached things before Bryce decided to send me a pineapple via the Glynet AR150. Do very, very quick hardware teardowns on both just to ensure that they're using the same chipset. The attacks that Pineapple uses, the Karma and Mana attacks that are still used to this day. So how we go about detecting those things in the field, and then of course the actual hardware itself. And then we'll all just kind of bow our heads and pray to the demo gods and hope that our demo works out all right. So firstly, of course, what is a Wi-Fi pineapple? I find that most people don't have exposure to some of the internals, at least from the software perspective, of what a pineapple actually does. We'll kind of very lightly go over those things. Like I said, this is a pretty pared down presentation to fit in our 30-minute time slot here. So in short, it is essentially man in the middle made easy for Wi-Fi. In some cases, especially with the Tetra and with homemade solutions, you can use up to 3 radios without any sort of lag. You need one for monitoring, one for stations for people to connect, and one for clients to give any of your victims that internet access to ensure that devices connect successfully and that they don't know that they're actually being attacked. In the last decade or so, I mean, there's been 6 generations of Pineapple. We're on generation 6 now. The current view that you see in the bottom and the right-hand side of your screens are the current generation of software. For the people that have been around a while, you might remember the sort of like green and black and red sort of hacker view that Pineapple used to be. And it was, you know, you felt cool using it, but it was a real pain to use. Things have definitely gotten much, much better. The module system is actually, I wouldn't say a pleasure, but pretty easy to use. So if you are looking into utilizing the Pineapple for some of your operations, I'm not going to heartily endorse it, but the modules are very easy to use. So there's definitely some cool things that you can do that not a lot of teams are doing out there. So like I said, when I started, I didn't actually have access to a Pineapple, but I knew I wanted to build this detector. So it actually turns out that there's a pretty wide community for building the Pineapple using off-the-shelf hardware that's much, much cheaper. So I kind of started my research here on Hack5's official hardware page, where they mentioned their Atheros AR9331 chipset, which is a relatively common chipset, and especially in embedded devices. Atheros is all over the place. But we can see here they use that system on chip. So of course we use this as our jumping off point, and we see where else this chip is in use. And of course I mentioned the Glynet AR150. Like I said, this is a pretty popular option. And it's very inexpensive, and you'll see when I do a quick teardown on this, it's really just one chip. It's really not a complex system. Like I said, it's $25 or under. Sometimes you can find them used for 15. So if you're really looking for just some simple research, a very easy way to build a Pineapple Nano is to simply buy one of these and flash the Pineapple firmware onto it. As I mentioned, you can see on their page, the page on the right there is directly from Glynet's page. They say that they use the Atheros 9331 SoC. So as far as we know, they use the same chipset and we're ready to go. There's also a USB port on the back that you can plug a hub into and connect all the devices you would like. That being said, it really only supports 2 additional devices along with the internal chip. And even then it's pretty slow, but it does work pretty well, especially for the secondary and tertiary radios. So just a very, like I said, very quick tear down here. It has an STC ID on the back there. Obviously, it's an approved device, so we could do the tear down that way, but it's only a single chip. So you'll see in the next slide here that we just decided to tear it out and just kind of see, how it worked. That chip in the center there, that little black guy is an Atheros 9331. It does have 2 Ethernet ports with a WAN and a LAN. We're actually reversed in software. If you do end up doing this on your own, and of course these slides will be shared out to you guys, you'll notice that there are some quirks with the software. If you are to install the newest firmware, there are some software changes you have to make, and I go through how to build the firmware in just a little bit here. You also need power and reset buttons during setup, so those are also included on the Glynet, which made things very, very useful. So these are the internal chip photographs. You can see here on the right side is the STC ID for the Pineapple Nano. And you can see, you probably can't read it there, but it is an Atheros, I promise, an Atheros AR9331. And we see the same chip on the left. So as far as we know, at least the wireless hardware is compatible, and everything else is sort of, we'll figure it out as we go. The good thing to note here is that the Glynet AR150 comes with OpenWRT preloaded, which is a huge help to us researchers because OpenWRT is open source and we can build basically anything on top of it. To that end, that link in the center there for GitHub, the OpenWRT CC from the Domino team, they have a repo specifically for the Glynet AR150 that builds any OpenWRT image directly for it. And if you want to do this yourself, you can go directly to the Hack5 firmware page, pull the latest firmware, and extract it with firmware modkit, and then essentially just copy those files into the OpenWRT CC/files directory, update, install, make the menu config, and you're good to go. You're ready to flash with that image that's been built. There are, like I said, there are a few software quirks, especially in the later versions. You kind of have to make sure that it's all PHP, so it's relatively straightforward. There's a lot of documentation online, so feel free to Google around. If you have questions, of course, feel free to reach out. But so what happens once we build it? Like I said, it's running OpenWRT. So if we go to upgrade the firmware directly from Glynet's administration panel, we can literally just drag our built firmware onto their installer and flash it on. Which again is just a researcher's dream. It's been very, very easy to research with this device. And there's of course Pineapple running our new Glynet AR150. If you'll note, I mean, Pineapple's been around for a long time. It's gotten more and more difficult to exploit new client devices. Clients have gotten smarter and smarter over the years. So in our case, we needed to apply both secondary and tertiary radios connected to a legitimate wireless access network to ensure that clients will go to connect to us directly. And a lot of new clients will check to ensure that they have internet access. So we need to provide that internet access to make sure that those clients will complete their association with our evil access point. So this is my actual installation that's on my desk next to me over here. It has, on the left side, you see the Glionet AR150. On the right side is a USB hub with a spare Etamax little USB Wi-Fi card that I had. And of course, on the south side there, you see the very popular Alpha N wireless that's used for the injection phase of our attack here. So all in all, there's an internal radio that's acting as our station. The USB, the small USB there on the right, the Etamax, acting as our monitor, and then the Alpha acting as our client. So very, very quickly here, I'll just kind of go over the Karma and Mana attacks that Pineapple, the Hack5 Pineapple uses or has used in the past to exploit clients. A long while ago, some researchers came up with an attack called Karma. And it used to be that devices would broadcast probe request frames that contained what's called a P&L. And those P&Ls had a list of networks that it wanted to connect to or preferred to connect to. So what Karma did was it would clone one of those ESSIDs and then start up a custom network stack that would just let people connect to it. And of course, on the clients, they don't mind when a single BSSID has multiple ESSIDs. That's obviously no issue. It's still not an issue today. But in this case, Karma, again, this was back in 2004, it was basically an automated evil twin attack. So very quickly, I want to say in just a few short years, this attack was outmoded in favor of Mana, which was the updated version of this attack, which still works on devices today, as long as the internet is available to that client. So nowadays, devices probe for networks much less frequently, but they do probe for networks. You notice when you come home from a long day at work, your phone connects to your Wi-Fi, so it has to probe for that network, and your access point will respond with a directed probe response. So your device is broadcasting to the ESSID and BSSID with all Fs in hex, looking for anyone to respond to that. So what Mana will do is essentially respond to anyone that asks for an access point with its MAC address, with its own destination MAC. So if you probe for a random ESSID, it will also respond to that as long as the software allows it to. And again, these are some very simple custom network stacks that some researchers came up with. Very, very simple kernel driver modifications that resulted in some pretty major damage around the globe. So like I said, Mana responds with directed probe responses, and we have ways that we can take advantage of that, which I'll kind of talk about here in a second. Two stipulations here for our detection of the Pineapple's attacks is that the Pineapple filters, by default, it used to be that they were open. Now, when you set up, it asks you if you want your filters to be open or closed. You can still, of course, use the MAC and SSID behaviors. That's more of a passive detection. I include a link later on from a repo called PyDents from some researchers that have done some work in the last few years that do some passive detection of the Wi-Fi Pineapple. But of course, we're after this active detection. So in order to do that active detection, our Pineapple has to accept our probe request, which of course means it has to go through the filter. Of course, with the advent of MAC randomization, a lot of red teamers and operators in the field tend to open up those filters a little bit more, which allow us to kind of get around those filters in a lot of ways. So you might have wondered what DRAIN actually stands for. DRAIN stands for Didn't Realize All Insecurities Needed Naming. I really hate acronyms, and so this was my acronym for them. So that's how do we go about attacking specifically Mana? Karma is not really in use anymore. So two assumptions that we make when we go about our detection methodology. One is that the beacon response is enabled. This is by default, and this is pretty much expected with most, if not all, Wi-Fi operations. Beacon response lets an arbitrary, lets you respond to arbitrary clients. So when a beacon request comes to you, you respond to that beacon with your MAC address. And of course, like I mentioned, the filters must not exclude our detector. It is possible that filters aren't there, but in that case, you're probably safe to be on that Wi-Fi network anyway. Wi-Fi is a pretty old protocol with WPA3 coming around. Things might change a little bit here, but the coffee shop attack is still something that happens on a daily basis. So like I said, Drain only covers active detection, and there's that link right there if you want to check out PyDents. Wi-Fi Hunter has several repositories that cover passive detection. Some of the code keys will updating as of 2020, but most things still work. So definitely give that a shot if you feel like if you have a Pineapple home or if you want to build one out of the Glynet AR150. So how do we go about detecting this in real time? So our detector, which we built on a Raspberry Pi Zero W, firstly just sweeps the active stations in the area. This is a pretty common thing that happens, on a second-to-second basis, on a millisecond basis by most client devices. In our case, we're simply going to note all of the MAC addresses in the area that respond to our sweep. And then we send probe requests for a random string to the broadcast BSSID. So basically we're saying, I'm looking for this remembered network. Does anyone in my current area have that network? And then simultaneously, we listen for a beacon response. So we have two things that we're looking out for. One, that a response station's BSSID matches the probe request. So that's that random string that goes out. If we get a response to a random string, that is very, very suspicious. There is not a lot that should be responding to a random string. And then, of course, our second confirmation is that one of those BSSIDs was in our initial recon. So that means it's an active station that's listening for connections, and it has responded to a random string for association. So both of those together means that more likely than not, we have a Pineapple or potentially a different malicious device. One other assumption that we'll make here is that an attacker has changed the sort of default MAC addresses to ensure that none of this stuff is easily passively detectable. Obviously, there are lots of other things you can do. Again, look at PyDents for some examples. So we need to make sure that we're only detecting the active detection, the active Pineapple itself. So onto building our detector. How do we build our detector? It's very, very simple. It's almost entirely in software. We use a modified kernel that comes with the Kali NetHunter repo that lets you do monitor mode. In our case, we actually don't need it too much. We can actually use some simple built-in IWS and IW scan commands that come with the kernel by default. It actually turns out, if you don't know, that if you provide a specific name to IWS scan, it will actually send a probe request to that name. So we can sort of scrape the output and use that with a default device. We don't actually need this modified kernel, which is, again, great news for sort of mass producing this. If someone were to mass produce it, is that you don't need a secondary radio to make this work. Like I said, we use the Raspberry Pi Zero W. It has 2.4 BGN. It doesn't support 5, obviously for now, to cut down on costs. So that might be a vector you might want to think about. You can obviously load the software onto anything that supports the same code. It just has a standard male 2x20 GPIO. You can sort of see the 1x8 LED matrix that takes up that 2x20. It's the Pimoroni blinked. It's a great piece of little software. It comes with a very easy to use library. So if you haven't used anything from Pimoroni before, highly recommend it. It's a little bit on the higher end of price, but very, very easy to use, and the libraries are really well done. So in that way, we've built this small piece of hardware that's kind of giving us a visual indicator if there is a Pineapple in the area. And that case is just a Pibo Zero W case, very, very cool looking case. So this is something that you just keep next to your laptop. Of course, you could also implement this fully in software for various operating systems as well. But that way you don't get to have a cool little light up device next to you, which is obviously the goal here. So with that, with 20 minutes in, it's demo time. So again, we bow our heads in honor of the demo gods. I'm just going to reshare my screen to ensure that I can give you guys my console output. Hopefully I haven't lost too many. All right, hopefully you guys can see this okay. So I'm connected to that Raspberry Pi on the left, and on the right side is just our live pineapple detector. There we are. So I'm just going to start up the scanner here, which is again our drain attack, and you can see, hopefully you can see it's not too much lag. That every few seconds our Raspberry Pi is simply scanning for any potential open networks in the area here. And it's just got some nice solid green lights, and you know, it looks all cool. So I'm just gonna scroll. I'm gonna come back here and just plug in this pineapple, and it's gonna boot up here in a second. The glories of virtual conferencing. So now our pineapple's been plugged in, and it takes about 30 to 45 seconds to start up. So right now our pineapple detector is just sweeping the network, looking for open networks, and that's it. And it just does it in a loop until it finds any open networks that are potentially in use by Raspberry Pi. I'm sorry, by a pineapple. Once it finds a potential open network, potential target, it will target those in a next phase, and it will send those directed probe requests and see if it can detect that specific BSSID as a pineapple. So hopefully here in a few seconds, we'll see this pineapple start up. Okay, we can see it found a hidden network with the BSSID Bobo Dead Beef, which, if you're familiar with that, is not a normal MAC address. So this next phase here, after the third scan, it will go and try to probe that one. So it says it's found a pineapple, and now our pineapple detector is flashing red, meaning there's an evil device in the area and that we should discontinue our wireless access immediately. This is the string that, of course, generated for the probe request. And then we can see that we got the SSID back to us from that probe request, and that it was the same Bobo Dead Beef MAC address we got directly back. That was in the initial recon phase. So this is an evil device. We should obviously not be using Wi-Fi in this area. It's very evil. And that is about it. If I just head back to my presentation here. Just go to this questions page. That's my email address. If you weren't aware, I work for Stage 2 Security. You can feel free to send me an email, or you know, I'll be on the BSide Slack for the majority of the year if you have any questions. If not, then thank you for watching. I appreciate it.
Thanks, Jason.
There is one question in the QA for you.
Oh, sure. I'm clicking on QA, but it's not actually doing anything.
The question says, what would happen if there were multiple pineapples in one area?
Gotcha. So in our case, that phase 2 portion actually does individual probes for each one that it finds. So our code specifically will just probe for both of those individually. But you know, obviously, if someone has more than one station, you probably have a bigger issue on your hands. But our code will just simply probe those individually. Yeah, that's about it. Wondering why I can't view these questions. Oh, there we go. Awesome. Well, thank you guys. Really appreciate it. This code will go up on probably GitHub, if not the Stage 2 Security GitLab or something similar pretty soon here if anyone's interested. And of course, feel free to hit me up with any questions.
Okay, thanks, Jason. Yeah, cool demo. That's pretty cool. Okay, so up next, we got Eddie. Eddie, are you on the Zoom at this point? You are.
Yes, I am.
Okay,
Can you hear
great.
me?
Yes, I can hear you. So I'm going to hand it off to Eddie now to present. He's got a really cool talk lined up about code signing, I believe. And yeah, feel free to start whenever you're ready.
Hi, everyone. Can you see my slide now before
Yep.
I get started?
Slides
Okay.
in and you're sounding great.
Okay, perfect. Hey, it's great to be here. Thank you. And I've got a lot that I want to cover in the next 25 minutes, so I'm going to just get started. So a few years ago, this company was in the news, Maersk. They're the world's largest shipping conglomerate. As you can see here, very, very large, and they're responsible for about a fifth of the world's shipping capacity. And they had a really bad day on June 27, 2017. And not sure if any of you remember what happened then, but this is what their employees experienced. Their computers started to display a screen like this. And what had happened is that NotPetya malware struck Maersk, and it infected 4,000 of their servers, 45,000 PCs, basically destroying all the data that they had. So it took them multiple weeks to restart and restore from backups, but this impacted their entire operation. Their voice over IP phones stopped working. Their ships that were out in the ocean stopped moving because their navigations went down. Port terminal gates stopped going up and down, so customers couldn't deliver their goods or get their goods from their ports, and it disrupted customers all around the globe. It took them about 10 days to start to bring things back up. They had to do it from backups, and their accountants basically arrived at a $300 million cost to them. But most external experts believe that it was much, much higher than 300 million for this much downtime for this company. So huge situation for them. But it didn't affect just Maersk. It affected these other companies. My brother works for Merck Pharmaceuticals, and at the same time, I remember hearing that he couldn't go to work because their computer systems were down and impacting physical security systems and computers and all of that. So it impacted a subsidiary of FedEx in Europe and some of these other well-known international companies. All in all, there's about $10 billion of estimated damages around the world. So huge situation. And how did it happen? So after investigation, basically this problem got linked back to a small Ukrainian business. It's a family-owned business called LinkOS. And they basically provide TurboTax-like software, but for Ukrainian businesses. So every company that does business in the Ukraine, they needed to use this particular software package. And we all know what's been going on politically between the Ukraine and Russia. And what had happened is Russian hackers had infected LinkOS with NotPetya, and that in turn infected all of these companies. And it was a very virulent piece of malware, and that's why it impacted so many companies, and it impacted them extremely quickly. There was an account for Maersk that they were literally trying to go around to every office and unplug their computers, and they still, couldn't stop it. So you have to ask, how did this happen? And if LinkOS was using code signing, if Maersk was vetting the software that was being installed on their servers, they should have been using code signing. And so obviously there's a failure of some sort, and it had $10 billion worth of consequences around the world. So we got to think about the risk. And I'm always one who likes to think about the risk. And there are basically two sides of the same coin. And as a group of InfoSec professionals, it's which of these are more would be more urgent for your business? Is your business more like LinkOS and you're providing software to customers, and so you're therefore concerned about the risk of what happened to LinkOS impacting your business and you infecting your customers? I mean, that would be really bad, especially if you're a software tech kind of company. Or are you more concerned about the risks that you might have that Maersk had, where they had a disruption of their business operations? Again, if that happened and your business was down for 10 days, it's going to be extremely disruptive and extremely costly. And frankly, I'm concerned about both. And I talk to customers, and obviously, they'll, depending on their business, they might be more concerned about one or the other. But it's a lot here for you to think about. And I know code signing doesn't always come to top of mind when you're thinking about the risks that you have to contend with on a daily basis. But this is a great example where it did some tremendous damage. And this leads us to a simple fact today. Software supply chains are more vulnerable than ever. And why is that? And first is that we're all experiencing digital transformation. So our businesses are relying on software more than they ever have. Our employees are downloading software from the internet. Sometimes we know about it, sometimes we don't. And every time they download it, we run a risk of infecting our systems with malware. Our software infrastructure comes from many different suppliers. I mean, at the company that I work for, it's a fairly small company, but we probably have between 100 and 150 different software suppliers in terms of the applications that we use for our business operations, as well as open source libraries that we use in our product and other libraries and software that we use in our product. And then finally, we get the issue where cyber criminals are now more active and creative than they've ever been. And that's really what the rest of this talk is about, is how are they doing it and what can we do to stop that? And Maersk was just one example. I mean, this has been going on for a while. Just last year, the Taiwanese computer manufacturer ASUS had a situation where hackers discovered some of their private code signing certificates. They inserted malware into legitimate ASUS software updates and then re-signed it with ASUS's private code signing keys. And this got pushed out. And I'm going to talk about that particular incident in more detail in just a few minutes. But we think back a few years even before that, there was issues around Stuxnet and what happened in Iran and their nuclear processing equipment. And if you look on the dark web, code signing certificates and keys are a hot commodity, especially if they come from a trusted brand name. So, if you work for a company where the brand is highly recognizable, and someone gets a hold of your code signing certificates, basically anything can be signed. And cyber criminals know that, and they sell them on the dark web. McAfee did a research project a few years ago, and at that point in time, so I think this was 2018, they've discovered 22.5 million pieces of malware that had been signed with either stolen or forged code signing certificates and credentials. I mean, that's a lot of malware out there that's being signed from using legitimate code signing credentials. So I started this off with a story because I really wanted you guys to take notice that this is a big concern for us, all of us in InfoSec, that we have to care about this. And what we see frequently when we talk to our customers is it's not always a high priority issue. So the rest of the time that I have, I'm going to just give a really quick refresher of what code signing is, what challenges we see and we hear about from our customers when they try to do code signing and protect those credentials. And then I have some tips for how you can do that moving forward. And then finally, I'll give us some time for me to answer some questions if I can. So what is code signing? Really simply, it's just a digital certificate, a digital signature that we use to sign computer executables. And a computer executable can be anything like an application, a mobile app, a disk image, drivers, firmware. If it runs on a computing device, it's considered code, and that code can be signed. And it does two things. One is it verifies, or it's supposed to verify, the author's identity. So if I work for company XYZ and I sign a piece of code with company's XYZ code signing certificate, everyone out in the world needs to be able to trust that really did come from company XYZ. And furthermore, it ensures that that piece of code doesn't get modified en route between when we release it and when someone actually downloads it and installs it. So it's basically meant to protect from malware from being inserted into a legitimate a piece of software. So that's what code signing is in a nutshell. And you can kind of think of it as a birth certificate for the software. So, we spend months and months developing software, and at some point we want to release it. It's like the birth of it, and then the code signing certificate is like the birth certificate saying, yes, you can trust it. It comes from us. and it hasn't been modified by anyone else. And then we think about, okay, an organization, who's responsible for code signing? And this varies widely. Some companies, they leave it up to their software developers because they're developing so much software so quickly. They have really aggressive schedules, and it's just there's no visibility to the InfoSec team that code signing is going on. And if the InfoSec team did it, they may not be able to keep up. If it's done by the development side of the house, they're probably using either build engineers to run a code signing script, or they're actually doing it as part of their build infrastructure. So I'm guessing a lot of you probably have companies that are embracing DevOps, and that's all driven through automation. So it's those scripts that are actually doing the code signing. But then there are some companies who take a different approach, and they basically want to centralize code signing because they understand the risk of those keys becoming getting out into the wild. So they have either their PKI team or their InfoSec team be responsible for all code signing operations. And like in life, everything's a balance between positives and cons for these ways of doing it. In general, if developers are signing code, they're going to be doing it on either their own personal workstation or laptop. They're going to be doing it on a web server, a build server, or maybe even in the cloud. And then obviously, if the PKI team's signing code, it's done in a secure vault. We have one customer that this secure lab isn't even connected to their internal network. It's completely isolated, and they actually have to take physical media into this locked room to do the code signing operations. And obviously, if they do that, it can't be very fast. So when we look at the pros and cons, if it's done by the software developers, it's going to be extremely fast. It's going to meet the demands of business, but it's likely to be very insecure because most software developers do not appreciate the risk around code signing, and especially if it's not protected. So they'll do what's convenient for them. They'll choose to do things that makes their job go faster and for them to be able to put out software faster. On the other hand, if you have the InfoSec team doing it, it's going to be highly secure. They understand the risk. They want to protect it, protect those credentials, but it's going to be extremely slow. It's going to, someone's going to have to take a USB flash stick and run from the development side of the building to the InfoSec room. So extremely slow. And both of these have pretty serious and significant disadvantages. And that's really what, as we think about the right solution, we have to be able to balance both. So let's talk about some of the challenges and the risks that organizations have. I'm going to point out this particular piece of literature. It's a paper from the SANS Institute, and it is really enlightening. It's a great read. It's very short. But basically what it outlines is that, yes, code signing is so effective that now cyber criminals are attacking the code signing infrastructure. So they're looking for those private keys. And once they have that, they're able to pivot and then actually attack the code signing system itself. So this is bad. They can either steal those keys or they can compromise those code signing servers. And in this quote, I found really powerful. It's not an exaggeration to consider private code signing keys as the keys to the business's kingdom. Now, think about that, and let me explain why I think this is so profound. When you sign a piece of code, as long as it was signed with a valid certificate at the time that it was signed, and it points to a timestamp server that has a valid timestamp, that piece of code is going to be installable for all time. So think about this. If a hacker signs a piece of malware with one of your valid code signing certificates, even if you revoke that, it's still going to be installable, and it's still going to look like it comes from your organization. And unlike what we might find with TLS or SSL certificates, and they expire after a certain period of time, so it kind of minimizes the damage done, and it's also only good for a particular IP address. Code signing keys, any piece of software can be signed with that if the hacker has the private code signing key. So let's talk about some specific challenges. The biggest one is private key sprawl and unprotected private keys. And when I say that, what I mean is that it's that scenario where developers have access to the private keys and they decide to put them wherever it's convenient to them, on their laptop, on a sticky note in their desk, on a build server, web server, you name it. If once you hand out a private code signing key, it's out there for pretty much forever, usable for pretty much forever. So let's look at this in a little bit more detail. Obviously, if keys are not protected, they're going to be prone to theft or misuse. And really, as I've said, there are unbound risk around this, is that you just don't know where they're stored. You don't know who has access to them, who's made copies, who's reused them, things like that. And there's a great example, and this is the example with Asus computers. And I wanted to walk through how this happened because I think it might be enlightening for you to understand the severity of what happens when you do have private key sprawl and the private keys end up in places where they're not supposed to. So with Asus, like with most computer manufacturers, they produce drivers and they produce updates to drivers that they would push out automatically to all of their customers. After all, that's the security conscious thing, to always plug security gaps with updates to software. And they did that. It was done automatically. Most people have their systems configured to where, as long as it has a valid code signing signature, their operating system's going to install it. But one of the things that Asus did that was really unusual, and again, a great example of private key sprawl, is that they had private code signing keys on this update server. And that is extremely bad practice. They should not be doing that, but they did it. At least 2 keys were found. Hackers were able to break into the system, and it was not too hard because it is, it's connected to the internet because it's their web update server. They browsed around to see what they could find. They found these 2 private code signing keys. And then what did they do? They inserted malware into Asus's update. So it's a legitimate update. They added their malware to it. If they didn't have access to those private keys, nothing would have happened. Their customers' computers would have rejected it because it would have been an unsigned executable, or it would have been a signed executable, but with a valid, invalid signature. But they found these keys, so they were able to sign their malware and the infected update. And then that got pushed out, and it infected Asus's customers. And it was an estimate of about 1 million computers were impacted. So again, if you're in the business to where you're delivering software to your customers, you have to think about, what would this mean to your business if you infected millions or 1 million customers with malware? And the scary thing is that Asus didn't know about this for months. They didn't realize that this had happened. And it was only after a malware company, I think it was Kaspersky, discovered this and then reported it to Asus. But I bet you there were some serious consequences at that company for allowing private code signing keys to be on their update server. So what does this mean from a business standpoint? And I know a lot of us, you aren't really thinking about things in terms of, this is what my company's revenue is, but it impacted their stock price, it impacted their revenue, impacted their market share. And it made their customers trust them less. And perhaps there's some liability issues there where, customers were asking for money in return of being infected. And depending on the segments of the market that they work at, there could have been regulatory fines as well. So pretty serious consequences. So that's private key sprawl. Another challenge that many companies have today with code signing is lack of policy enforcement. So, I'm sure we all know what's the right thing to do in terms of policy. Well, don't let the private code signing keys outside of a secure location, require some level of approval before they get used, things like that, a certain encryption strength. And I talk frequently with many customers, and they do have those policies defined. They have them written down, great little manuals sitting on their desk. But if there's no way to enforce that, then people are finding ways to bypass that policy. So if you don't have the ability to enforce policy, and when I say the ability to enforce it, it's an automation around being able to enforce it. People are going to figure out ways to bypass what you have in place because it's less convenient for them. And then you'll end up with code signing challenges. And there's also this issue of lack of global visibility. So if you're on an InfoSec team for even a large company with thousands of employees, your group is not that large, maybe 10, 15, maybe 50 people at the most. But if you think about how many people in your organization is actually writing code, and then that code's getting signed, it's happening all around the globe. And you probably don't have visibility into everything that's going on. But if there is a breach of some sort, like with what happened with ASUS or with Maersk, what's going to happen? They're going to come to your team and say, how did you let this happen? So it's really imperative that we do get global visibility. We need to understand things like what code signing certificates are being used, what pieces of software use those code signing certificates when they got signed, who did a code signing operation, things like that. So without that global visibility, it's really hard for you to even gauge the magnitude of the risk that your organization has. And then we also have to deal with rogue development teams. I'm an old software developer. That's my background. And really, software developers, they have so much pressure to get out new features and get out new features faster than ever before. And they're focused on testing and integrations and things like that. Security usually falls pretty low on their list of priorities. And if as a InfoSec team, we're trying to put process on them and say, well, you can't do things this way. You got to go through this set of manual steps. Development teams are going to find workarounds. And we see this all the time with our customers, is that they find workarounds, they go rogue, and then they put the company at risk because they just need to be able to move fast with their software releases, and they'll code sign in any way that they can. So just to finish up here, I wanted to leave you guys with some tips that we have on how you can make this better for your organization. And I'll walk through each of these in just a little bit of detail. But before I do that, I want us to think about code signing a little bit differently than we think about other kinds of PKI information. Code signing is really a process. And I say it's a process because it involves people. So these are the people that are actually doing the code signing operation. It involves things like the code signing certificate or the keys, and it involves activities. So it's actually, the exercise of actually running that code signing command to create the digital signature for that piece of code. And if there's a failure in any of these areas, so if this is insecure, if we can't control who has access, if we can't control the actual keys, if we can't control what gets signed, that means the entire thing's going to fail, and there's going to be a vulnerability across the board. So as we think about protecting code signing, we have to think about how do we do that in terms of securing the entire process. And that's what these best practices are centered around, is how can we secure that process. So first one I want to talk about is really, it should be obvious to all of us. It's to secure those private keys. And to secure those private keys, we're either going to put them into an HSM and keep them there, or into some other kind of encrypted storage to where we limit the access of who can get to those. And the thing is with secure storage is that if that key needs to come out of the secure storage in order to do a code signing operation, it's immediately not secure anymore, because someone can easily make a copy of it, and then at that point, that code signing key is not secured, and we're back at square one. So secured storage means they're in a safe location, and that they never leave that location once the key gets created for any reason. So the next best practice is to provide your teams with enterprise visibility. So even if you have development teams around the world, you want to be sure that you know everything that's going on around code signing, because it's an important part of securing the business. You need to know who assigned what pieces of code, when did they get signed, what build servers or what servers were used to do the signing operations, what code signing tools were used, what time of day, what days of the week. All of that is really important information for you to have, because it helps you to build risk trends and be able to identify patterns that might indicate that a code signing credential is being misused. Next step is you need to control the process. So you need to be able to say, okay, only these select people can access the key. And when I say that, I don't mean they actually have the key. They can access it for a code signing operation. You need to be able to specify who should approve the use of that, because that is a very important control mechanism. That if I'm a developer, I shouldn't be able to use that key whenever I want to. There should be some approval process in order for me to use it, because that's how critical these are. So we need to be able to say, this person has the authority to approve the use of that particular key. If There are requirements around encryption strength or which certificate authorities are used or which HSMs should be used. That should all be defined, and you should be able to have a way to automate that control. And then we need to think about an automation process that's convenient for developers. Again, I go back to that whole notion of rogue development teams, and they go rogue just because it's easier for them. So it really becomes important for us to find a solution that is going to make their life easier, and it's going to make them want to use the solution in place. And that usually means don't make me learn something new, and don't slow me down from what I normally do, and allow me to work with the tools that I already use. So those all are really important to keep those development teams happy. And then finally, you need to be able to have intelligence around what's going on within your organization on code signing. You need to, in some cases, you need to show compliance that yes, your policies are being followed. You do know you have visibility into every code signing operation that occurred. You know who's accessed what certificates, and be able to identify risky trends that might indicate a problem. And then again, this has to be developer friendly. And I'm saying this twice because it's that important. We have so many customers that we work with that they have tried their best to create an infrastructure that secures code signing, but it's inconvenient for their developers. And so their developers will grumble for a while, and then eventually they just stop using it. And when that happens, they're back to square one of having an insecure process. And finally, I just want to leave you with this white paper. It's really, really useful. A lot of what I covered in the best practices comes directly from this. It's a NIST paper that talks about what security considerations your organization should put into place to protect code signing. So with that, I'd like to thank you for your time and wish you all a great weekend. And I'm happy to answer any questions.
Okay, Eddie, I think there's one question for you in the Q&A.
It's about revoking code signing keys.
Yeah.
So you could revoke the certificate, but the problem is that if that certificate has been used to sign a piece of code and a timestamp was used, then even though you've revoked it, it's still going to be a valid piece of code that's going to have a valid signature. That's the whole reason why this is so scary for me, at least, that you don't take all the precautions, and then your key gets out, your private key gets out, someone signs some malware with it. There's really nothing you can do at that point.
Okay, cool. Well, thanks so much, Eddie, for presenting. Appreciate it. I think that's the only question in the queue. I really appreciate everybody coming out today and jumping on the Zoom, and for all the questions in chat. Just as a reminder, the CTF, which if you join the BSides Slack, and then via the link or button on the website, BsidesSLC.org, you can join the hashtag CTF room and get the details for the CTF. And that's going to be open until 3 p.m. tomorrow. So really appreciate Secure Code Warriors for putting that CTF on. Also really appreciate all the work that all the speakers put into their presentations today. In addition to all the work that Pope and team did on the media and recording and streaming to YouTube. That's amazing. They were able to get this all working in, basically a week. And, also just another shout out and thank you to the sponsors. Really appreciate your support and for all of you coming out and listening. We are going to email out a link tonight, another email, which will have the Zoom information for tomorrow morning. Just to reiterate, we will open up the Zoom at 9 a.m. tomorrow morning, Mountain Time. And then at 10 a.m., the conference will start. Waylon is up first, and he will be speaking about electronic badge he designed. And the schedule is up on the BSides website if anyone is interested in checking it out. If you have questions for the speakers or for myself, feel free to jump on the BSides Slack. I think most of the speakers are on there at this point. And yeah, thanks everyone for coming out. We'll see you again tomorrow at 10 a.m. when Waylon kicks off the talk. Thanks.